has two very well-known satellite galaxies, the Large and Small Magellanic Clouds. They were named after Ferdinand Magellan, an explorer who led the first circumnavigation of the globe a whopping 500 years ago. During this expedition, two groups of clouds were discovered in the southern night sky. Those are now known as the Magellanic Clouds. But they're not the only ones. The Milky Way is surrounded by at least 61 other galaxies within 1.4 million light-years. For comparison, our neighbor, the Andromeda Galaxy, is 2.5 million light-years away from us. And still, astronomers think there are many more satellite galaxies, perhaps even too many. But first, let's figure out what a satellite galaxy is. Our Sun is just one of a truly huge collection of stars in the Milky Way. Hundreds of billions of stars orbit the center of our galaxy. But something much bigger orbits the Milky Way's center too: other galaxies. They are way less massive, but have their own stars. We can compare the Milky Way to our Sun, and those other galaxies to planets. Astronomers call such formations satellite galaxies. The Milky Way's biggest satellite galaxy is the Large Magellanic Cloud. It's located about 163,000 light-years away and is about 1/100th the size of our home galaxy. Unlike the spiral Milky Way, the Large Magellanic Cloud doesn't have a clean spiral shape. One theory claims that it's because the Milky Way and other galaxies pull and warp it. In terms of distance, there are two candidates that can fight for the title of the closest satellite galaxy. One of them is so small that scientists consider it a dwarf galaxy. The other is so close that it's still debated whether it's a separate dwarf galaxy or part of our own galaxy. The satellite galaxy everyone agrees on is the Sagittarius Dwarf spheroidal galaxy. It's around 50,000 light-years away from the center of the Milky Way. But there's a cluster of stars that is even closer than that. Some experts call it the Canis Major Dwarf galaxy. It's likely to contain about 1 billion stars and is located so close to the edge of the Milky Way that it's actually closer to our solar system than to the galaxy's center. Some astronomers don't think the Canis Major is its own galaxy. They believe it's simply a dense area of faraway stars, which is still part of the Milky Way. Whatever the case is, this bunch of stars was once pulled toward the Milky Way by our galaxy's immense gravity. That's how most satellite galaxies in the area are likely to end up. Once, they might all merge into an even larger Milky Way galaxy. But let's get back to the assumption that the Milky Way has too many satellite galaxies. A team of astronomers has been hunting for such galaxies using the Subaru telescope. So far, they have searched a mere 3% of the sky. And still, they have found 9 previously undiscovered satellite galaxies. That's far more than they expected to spot. Interestingly, most of the satellite galaxies orbiting the Milky Way are newcomers. Yes, even the Large and Small Magellanic Clouds. This most recent research hopes to improve our understanding of our corner of the universe with the first detailed search for companion dwarf galaxies. However, the study also has another goal: to figure out dark matter distribution. You see, the current theory claims that the mass of our galaxy consists of 2 parts: visible matter, like stars and planets, and something invisible, which is hypothetical dark matter. We can't see it directly, but we can feel its gravitational influence through a certain distribution of mass in galaxies. Strangely, the simulation of the dynamics of the galaxy and this dark matter predicts hundreds of satellite galaxies in the Milky Way. Until recently, we only knew about a few of them, which created a contradiction known as the missing satellite problem. Hopefully, the new research will solve this problem. The team admits that so far their research has been based on statistically small numbers. Several assumptions have also been made based on a particular distribution of satellite galaxies. Follow-up studies of stars in the satellite galaxies and high-resolution imaging are definitely needed to progress further.
A Dyson Sphere is a theoretical megaproject, a ginormous sphere encircling a star with platforms orbiting in tight formation. It's supposed to be an ultimate solution both for energy production and living space. The creators of a Dyson Sphere get a lot of surface area for habitation and the ability to catch every tiny bit of solar radiation and heat produced by their central star. The first person to theorize about such a bizarre construction was British-American theoretical physicist Freeman Dyson. According to him, an intelligent extraterrestrial civilization could consider building this sphere after colonizing some moons and planets in their local stellar neighborhood. With the growth of their population, these aliens would need more and more energy to sustain their lives. Dyson calculated that assuming that this alien society grew at 1% per year, their area and energy needs would become 1 trillion times larger in a mere 3,000 years. And if their solar system contained a space body similar in size to Jupiter, they could take it apart and spread its mass in a spherical shell by building a structure at twice the distance between our planet and the Sun. This amount of material would be sufficient to build a huge number of orbiting platforms. Each of them could be 6 to 10 feet thick, which would basically allow this civilization to live on their star-facing surfaces. A shell this thick could be comfortably habitable and capable of holding all the equipment needed for using solar radiation without falling onto the star from the inside. But after absorbing all this solar energy, the sphere would have to re-radiate it. Otherwise, the energy would build up, eventually causing the construction to melt. It means that the light of a star wrapped in a Dyson sphere would look dimmed or even completely darkened, depending on how dense the platforms orbiting it were. At the same time, it would glow unusually bright in infrared wavelengths invisible to the unaided eye. Because of this infrared radiation, Dyson spheres are classified as a type of technosignature. It's a sign of activity that astronomers can use to discover intelligent life forms in the universe. Some Earth-based researchers have infrared maps of the night sky they examine in hopes of spotting Dyson spheres. So far, no one has ever found one. However, one study has selected several Dyson sphere candidates. Its authors have processed large amounts of information using a special data pipeline for combining and analyzing information. One of the main search criteria is the detection of excessive infrared radiation. At the same time, it's important to distinguish this radiation from that emitted by natural objects. After a complicated filtering of millions of objects, the researchers identified 7 potential Dyson spheres. Sure, further analysis is needed to determine their nature. To do this, scientists want to use optical spectroscopy, which may reveal more details about these objects and their origins. At the same time, the researchers admit that these candidate Dyson spheres might have other explanations. For example, they could be debris disks or protoplanetary disks of young stars. Only more research can show whether we can find traces of other civilizations among star systems. For now, it's still an open question. Interestingly, Dyson spheres have been spoken about a lot in science fiction. As far back as 1937, a novel called Star Maker by Olaf Stapledon described systems in one particular galaxy that were surrounded by a gauze of light traps, which focused solar energy for intelligent use. That was the reason why the entire galaxy was dimmed. In another novel, Ring World, the writer spoke about a ring-shaped artificial structure surrounding a star.
The universe is a big, mysterious, and ever-changing place. But just like we have baby photos that show how we looked when we were little, scientists also have a baby picture of the universe. Only they were able to look 14 billion years into the past. How is it possible? Well, let's figure it out. Imagine winning the Oscars of science for a picture that shows the entire universe when it was just a baby. Scientists achieved this fantastic feat using NASA's Wilkinson Microwave Anisotropy Probe. To take this picture, they built a super cool satellite, launched it into space, and collected massive amounts of data about the universe. This image turned out to be a cosmic treasure trove. It helped answer some of the universe's biggest questions, but also revealed a few new mysteries. This groundbreaking data confirmed the standard model of cosmology and told us that our universe is around 13.7 billion years old. Plus, it showed us that the elements in our regular periodic table make up only a tiny fraction of the universe's recipe. To be honest, this is not quite a photo in the usual sense. Of course, we cannot actually photograph what happened so long ago. The picture we're talking about is called the Cosmic Microwave Background, or CMB for short. Now, the CMB is like a faint glowing light that fills up the entire universe in every direction. These clues that can help us understand how the universe evolved into what it is today. CMB is a super cool glow that fills up the entire universe. You see, when you look through a regular telescope, the space between stars and galaxies seems pretty dark. But with an amazing radio telescope, we can actually detect that this empty, dark space is filled with a super faint and even glow. This glow is all around us, and it's not coming from any star or galaxy. This is the cosmic microwave background, and it's strongest in the microwave part of the radio spectrum. The CMB is a frozen treasure, super chilly at around minus 455 degrees Fahrenheit. Bruh, that's colder than any winter you've experienced. This ancient light formed about 380,000 years after the Big Bang, which happened around 14 billion years ago. So we're looking way back in time. In the beginning, the universe was like a thick fog of incredibly hot plasma. It was almost 500 million degrees Fahrenheit. It was so hot that atoms couldn't even exist yet, only wild electrons and protons bouncing around like crazy. Because of this super hot fog, any light that tried to travel got scattered by those mischievous electrons. It was basically like trying to see through a foggy car windshield. But then, the universe started expanding in all directions, just like a cosmic balloon getting bigger and bigger. And it's still expanding today. As the universe did that, it began to cool down. When it turned 380,000 years old, it finally cooled enough for electrons and protons to come together. These tiny particles started to combine, forming mostly hydrogen atoms. When that happened, the universe finally became transparent, like a clear window. The moment of this magical transition is called the Recombination Epic. Once the foggy era ended, the light could travel freely. The universe became like a vast playground for light to bounce around and explore. And, as you know, light has a certain speed, 186,000 miles per second to be specific. And it takes some time for light from distant places to reach us. So, in other words, the CMB is the oldest light in the universe. It's like a capture from a moment when the universe just started to become clear and transparent. As this light traveled through space, it went through all sorts of adventures, like the formation of stars and galaxies. Along the way, it lost some energy and transformed into microwaves, which our eyes can't see, and that can be detected only with special tools. Also, there are some tricky things that can mess with the data. For example, galaxy clusters. These are big groups of galaxies hanging out together in space. When the ancient light from the CMB travels across the universe, it encounters these groups, and these sneaky clusters try to leave their marks on the CMB. They distort the patterns in the ancient glow, like smudging the ink in the important ancient book. That's why scientists have to invent techniques and supercomputers to help clean up this mess and decode everything properly. Due to all this, the CMB isn't perfectly smooth. It has a few little bumps and patterns. These weird patterns make it unique, kind of like the universe's fingerprint. Scientists have been using amazing tools like the Cosmic Background Explorer and Wilkinson Microwave Anisotropy Probe to study these patterns. The COBE, our cosmic camera, took the first ever map of the sky in microwaves from 1989 to 1993. Why do we study it? Well, because the CMB can help us learn so much about the early universe. Stuff like how it expanded, how much normal matter and mysterious dark matter it had, and even the overall shape of the universe, and much more. We're basically playing detective with the cosmos, trying to decode the mysteries of our world by little clues and prints. What are the results? Well, awesome tools like the Wilkinson Microwave Anisotropy Probe helped us to learn more incredible facts. For example, we found out that we can actually only see 5% of the universe. Imagine the universe as a cosmic pie. Scientists learned that 68% of it is made up of something called dark energy, and 27% is dark matter. Only a tiny 5% is made of normal matter, the one that we, humans, can see. So, most of the universe is like this hidden realm we can't even imagine. We also found out what happened in the beginning of times. Picture the universe right after the Big Bang. It was so tiny, way smaller than a proton. Everything we see today was crammed into this itsy-bitsy space. The rules of quantum mechanics, which let weird and wild things happen, were in full swing back then. Matter and energy were like playful adventurers, borrowing from the future and disappearing into nothingness. Then, cosmic inflation happened, and the universe suddenly expanded like popcorn on a cosmic scale. It became a trillion times bigger than it was, creating waves of gravitational chaos everywhere. Some gravitational waves filled the baby universe like a sea, and their patterns left unique fingerprints on the CMB light. And all that learned thanks to the pictures of the CMB. Anyway, NASA has this awesome plan to study the universe's baby picture. They're going to use a really cool observatory called PIPER, which stands for Primordial Inflation Polarization Explorer. Imagine PIPER as a special space balloon that's going to fly up high in the sky from a place called Fort Sumner in New Mexico. It has two powerful telescopes that sit in a hot tub-sized container filled with liquid helium. This liquid helium is super cold at around minus 452 degrees Fahrenheit. But PIPER loves the chill because it's extremely sensitive. What is its mission? To learn all about the early days of the universe, right from its first baby picture. When PIPER is up there, it's going to look very carefully at the CMB, trying to find some hidden patterns that hold the secrets of how the universe grew and changed over time. This spy with a magnifying glass will be examining 85% of the sky. PIPER's launch is scheduled for late September. You can even watch the exciting balloon filling action live on the Columbia Scientific Balloon Facility website. It's going to be out of this world fun. So the cosmic microwave background is like a time-traveling storyteller, giving us valuable clues about the universe's incredible past. Isn't that awesome? Space is full of surprises, and there's so much more to discover. Keep your eyes on the stars, and who knows what else we'll find out there.
For a few decades, scientists have been debating whether there's a mass gap between the heaviest neutron stars and the lightest black holes. And finally, for the first time ever, researchers have discovered an object with a mass falling right into this gap. It started on the 29th of May, 2023. The LIGO Livingston detector in Louisiana recorded a mysterious signal. It was produced in the process of a merger of a neutron star with an unknown compact object. It was most likely an unexpectedly lightweight black hole. Its mass could be just a few times that of our sun. That's why this object falls into the lower mass gap between the lightest black holes and the most massive neutron stars. According to Einstein's theory of general relativity, neutron stars are likely to be lighter than 3 times the mass of our sun. But the exact mass after which a neutron star will collapse into a black hole is still unknown. And considering our previous electromagnetic observations, we can expect to find very few black holes or neutron stars within the range of 3 to 5 solar masses. And still, the mass of one of the newly discovered objects perfectly aligns with this range. But let's have a better look at how the situation with the LIGO detector unfolded. Just 5 days after the launch of the 4th observing run, things became really exciting as the detector recorded a gravitational wave that was classified as signal candidate S23059A. The online analysis was performed almost in real time as the signal arrived, and the conclusion was astounding. A neutron star and a black hole most likely merged around 650 million light-years away from our planet. Unfortunately, it's impossible to say exactly where the merger had occurred since only one gravitational wave detector was recording scientific data when the signal arrived. That's why the direction from which the gravitational waves came wasn't determined. And still, the researchers were sure that the signal wasn't some local disturbance in the LIGO Livingston detector. It actually came from deep space. To figure out the properties of the space bodies that orbited each other before merging and producing the gravitational wave signal, astronomers compared data from the LIGO Livingston detector with 2 waveform models. The detected signal appeared as a result of the merger of a compact object with 1.3 to 2.1 times the mass of the Sun, and another compact object with 2.6 to 4.7 times the Sun's mass. Were these compact objects a neutron star and a black hole? We can't tell for sure using gravitational wave analysis alone. But based on everything we've learned about the properties of this binary, astronomers think that the lighter object is a neutron star and the heavier is a black hole. Of all the neutron star-black hole mergers we've detected so far, the most recent one is also the one in which the masses of the 2 participating objects are the least different. Experts explain that if a black hole is way heavier than a neutron star, no matter will be left outside the black hole after the merger. No electromagnetic radiation will be emitted either. As for lighter black holes, they can rip neutron stars apart with their strong tidal forces. In the process, they eject matter that might glow as a kilonova or a gamma-ray burst. The detection of this interesting phenomenon became possible due to several improvements made to the detectors, which increased the sensitivity of the equipment. The highly successful 3rd observing round finished in spring 2020 and brought the number of known gravitational wave events to 90. The 4th observing round started in May 2023. Researchers at an institute in Hanover, together with their LIGO colleagues, have improved the laser sources of the LIGO detectors located at the heart of the instruments. Along with hardware, experts have also worked on other features of the detector. And now, these space exploration tools can figure out the properties of black holes within mere days. Imagine living in a world where technology has reached its highest point. Your daily routines are orchestrated by an AI, which anticipates your every need, from brewing your morning coffee to selecting a perfect evening outfit. The cityscape outside the window of your floating home is a marvel of efficiency. Flying pods whisk people to their destinations. Renewable energy sources power the giant megacity, creating an environment of pristine streets and clean air. At work, you have online meetings with colleagues living across galaxies, collaborating on projects that go beyond our current understanding. It sounds like a sci-fi story, but some extraterrestrial civilization might have already reached this level of development. Scientists started pondering the possibility of life beyond Earth long ago. They've been wondering what such life could look like and how humans could identify it from afar. This train of thought led to the development of several classification systems, including one called the Kardashev Scale. It was proposed in 1964. This classification evaluates hypothetical alien civilizations based on how much energy they are able to harness. According to the scale, there are three types of civilizations. The first type is a technological level close to the current level of Earth. Type 2 is a civilization capable of harnessing the energy emitted by its own star. And the third type is a civilization that has learned to use the energy of an entire galaxy. This scale sure caught people's imagination. It was included in a 5-page paper called Transmission of Information by Extraterrestrial Civilizations. This work focuses on calculating how powerful a light signal from any point of the universe should be for us to detect it. Now, within the basic categories, humans are a Type 1 civilization on the Kardashev Scale. But some experts claim we aren't even a 1, since we haven't managed to harness the equivalent of the entire energy of Earth. This makes us more like 0.7, and of course, we're far from being a 2, a civilization with a working Dyson Sphere. A Dyson Sphere is a theoretical mega-engineering project encircling a star with platforms that are orbiting it in a tight formation. It might be the ultimate solution for living space and energy production. With its help, the creators of this ginormous construction could have loads of surface area for living and the ability to capture every tiny bit of solar radiation produced by their main star. As for a Type 3 civilization, it extracts fusion and exotic energy, information, and raw materials directly from their galaxy. This civilization is capable of space travel via wormholes, intergalactic communication via subspace, and galaxy-scale influence. They have supreme access to energy and are spread all over the universe. After millions of years of evolution, a Type 3 civilization may actually be AI superintelligences. Androids, cyborgs, and humans may be considered subspecies in such a highly advanced galactic society. In the most hopeful scenario, humans would have found a way to coexist with their AI masters. Or there might be no humans in that world whatsoever. This civilization might have already ascended into beings of pure energy, capable of controlling and directing machines to carry out all kinds of work. Now, back to the Kardashev Scale. Even though it focuses only on technosignatures, it acknowledges biosignatures too, suggesting that each search should inform the other. The discovery of the simplest organism, for example, on one of Saturn's moons, could increase the probability that many Type 2 civilizations exist in our galaxy. At the moment, SETI is the main player in the field of looking for extraterrestrial civilizations. It's a combined effort of enthusiast scientists who focus on receiving and analyzing signals from space in the radio and visible light regions of the electromagnetic spectrum. It's looking for non-random patterns that have been likely sent deliberately by technologically advanced beings. The first modern SETI search was Project OMA in 1960. It used a radio telescope in Green Bank, Virginia. SETI uses targeted searches concentrating on groups of nearby sun-like stars.
We still can't find the source of the mysterious signal we've been receiving since 2018. We receive it every 22 minutes, and nothing can explain this. Some scientists even believe it could be coming from another civilization we haven't met yet. This strange radio signal wasn't found by a scientist on a serious mission. It was actually discovered by a college student just doing a regular project for school. Tyrone O'Doherty, an undergrad student at Curtin University in Australia, was sifting through old data of the southern sky. He was looking for any weird blinking radio signals. He finally stumbled upon one from 2018 that seemed to shoot radio waves towards Earth like a lighthouse beam. Excited about his find, Tyrone shared it with his mentor, radio astronomer Natasha Hurley-Walker. She dove into researching this signal, hoping for a breakthrough. But despite checking different frequency data, they hit a dead end. But then, Natasha spotted a pattern. The signal repeated every 18 minutes. This was huge. But just as they were gearing up to study it further, poof! The signal vanished after only 3 months, leaving them with nothing. Not giving up, Natasha and her team scanned the skies again, desperate for a clue. Months passed, but nothing turned up. They were ready to give up, and then suddenly, a new signal popped up. This one kept blinking for 5 minutes, Then it disappeared. And then it came back exactly 22 minutes later. The main question was if that signal was related to an 18-minute one. To figure it out, Natasha went back to the old radio data from that area. As they dug deeper, they realized that, yes, and these signals aren't anything new. They've been beaming towards Earth for 35 years. Back in 1988, Indian and American telescopes had caught them, but they got buried under tons of other data. This was great news for space explorers because it meant they could now calculate how far away this mysterious object was. After doing the math, they figured out it was incredibly far, even on a space scale, 15,000 light-years from Earth. Now, the only thing left to uncover was what exactly this object was. Walker and his team started comparing it to all the known radio-emitting objects out there. Yet its source remains a mystery. The signals still pop up every 22 minutes on NASA screens, always ending with a frustrating match not found message. The scientists called it J183910. Some think that the signal might come from some extraterrestrial beings. Maybe it's the signal that SETI, the search for extraterrestrial intelligence, has been waiting for. This project has been working for over 50 years, trying to find any evidence of life beyond Earth. They also scan the skies for radio waves, laser pulses, and other mysterious signals. So maybe it's a way for extraterrestrial folk to communicate their location. While that idea may sound exciting, we need to be careful about jumping to conclusions. First, we don't have solid proof for that. Before any concrete evidence, it's just speculation. And also, there are other more plausible explanations. Most likely it comes from a natural phenomenon, and there are a couple of theories for that. The first one is the Pulsar Theory. Imagine a huge star in space, much bigger than our Sun. Sometimes these big stars finish their life journeys in a spectacular event called a supernova. When this happens, the star's core collapses, becoming super compact, as if you're squeezing all the stuff from that star into a tiny space. That tiny, super-dense core is called a neutron star. Some of these neutron stars are extra special. We call them pulsars. They get their name because they seem to pulse with energy, like a space lighthouse. These pulsars have incredibly strong magnetic fields, much stronger than what you'd find on Earth. They're like enormous magnets in space. Because of this, they shoot out beams of energy. They're also spinning super fast, so these beams of energy seem to pulse on and off as they spin around. Now, the strange signal we detected seems to have similarities with pulsars, but not quite. Pulsars usually have a predictable lifespan and slow down over time, eventually stopping their radio signals. In contrast, our mysterious signal is quite persistent and is blinking beyond what's expected for pulsars. So, maybe it's not a typical pulsar, or not a pulsar at all. There's also a magnetar theory. Now, a magnetar is another type of neutron star. They're like supercharged versions of pulsars, with even stronger magnetic fields and slightly longer pulsating periods. Maybe this is what causes our signal's intense persistence. However, when we plotted the data, we also realized the signal didn't match the magnetar's vibes either. Magnetars not only send out radio waves, but also powerful X-rays because they're so energetic. But the signal we received was only sending out radio waves. So we figured it's not a pulsar and not a magnetar. The signal's behavior is very strange and suggests an unnatural source. This means there might be something in the universe that scientists haven't fully explored yet. And there is a space object that we don't know much about. The final theory is the so-called Dwarf pulsar. Sounds a little dopey to me. Couldn't help myself. Now, a dwarf pulsar is like a star that blinks with light flashes, similar to pulsars, but it takes longer for each blink. Usually, white dwarfs are the leftovers from smaller stars. They don't blink because their magnetic field isn't as strong as pulsars. But when a white dwarf becomes pretty hefty, almost the mass of our Sun, It gets super dense and starts pulsating with a strong magnetic field, just like pulsars. They have a cool quirk. White dwarfs are made of electrons, not neutrons like pulsars. When these charged electrons start dancing with the magnetic field, they shoot out periodic light flashes, which happen every 100 to 1,000 seconds. As you remember, our signal has a period of 22 minutes, 1,320 seconds. A bit longer than the usual white dwarf pulsars, but it's much closer to the truth. So far, this sounds like the most plausible explanation. But even this theory isn't fully confirmed yet. This just shows how much there is in the universe that we're still figuring out. For example, fast radio bursts, another mysterious type of signal we've been detecting. They're like quick, intense bursts of energy in the form of radio waves. They have a ton of energy. FRBs are so powerful that sometimes they can be brighter than entire galaxies. Now, imagine this. They release as much energy in a few milliseconds as our sun does in 3 whole days. Wow! These bursts happen all over the sky with huge frequencies, although some have been detected with lower frequencies. Every day, we catch around 10,000 random FRBs in the sky. Some of them repeat, but most happen once and disappear forever. Unfortunately, most of them only last for a fraction of a second, and by the time their energy reaches us, it's 1,000 times weaker than a mobile phone signal from the moon. This is why, despite their brightness, there's still a lot we don't understand about them. We're still trying to figure out what causes these FRBs. They could be coming from different sources, like already mentioned magnetars, colliding stars, or even merging galaxies or white dwarfs. As these bursts travel through space, they pick up information about the cosmic environments they pass through, like interstellar gas clouds. It's very unlikely that FRBs are some messages from extraterrestrial beings, though. Not only because there are thousands of them every day all across the sky, but also because we know that the sources of these bursts must be incredibly energetic themselves. Our neighbors would have to have equipment stronger than entire galaxies for that. But the bottom line is, while all these signals are fascinating, there's still a ton to learn about them.
Space. The final frontier. It's a vast and mysterious expanse that has fascinated us for centuries. But as much as we've learned about it, there are still plenty of things that we've been lied to about when it comes to space. Let's take a look at some of the biggest lies we've been told about this topic. First off, we have the idea that space is just this pristine, untouched wilderness. But that's not exactly true. We've been littering space with our debris for decades. Everything from old satellites to rocket parts. In fact, there are over 20,000 pieces of debris orbiting Earth right now, and they're causing all sorts of problems for future space missions. So if you're planning on visiting space anytime soon, watch where you go. You never know what kind of garbage might be floating around. Did you know that the sun is not actually yellow? It's green. Well, kind of. You see, scientists measure the temperature of a star by the color spectrum it emits. Cooler stars appear red, while the hottest of stars look blue. Our sun emits most of its energy at a wavelength that's close to green. But because it emits other wavelengths too, all these colors mix together, and your eyes see this vibrant mixture as white. From Earth, however, the sun looks yellow because our atmosphere is really good at scattering blue light. If our star was actually yellow, Earth would become a frozen rock, and we'd all be polar bears. Plus, the sun isn't on fire for real. It's a big ball of gas, mostly made of hydrogen and helium, and it works more like a gigantic nuclear reactor, constantly fusing hydrogen atoms to create helium inside its core. This process releases enormous amounts of energy. That's why the sun is so hot. Oh, and speaking of setting things on fire, explosions in space aren't real. Sorry, Star Wars fans, a spaceship can't go down in a violent blast because there is no air out there in space. No air means no oxygen, and no oxygen means no fire. Now, you might also think that there are too many stars in the night sky for you to count, but in fact, you can do that. According to the Yale Bright Star Catalog, there are 9,110 stars that you can see from Earth with the unaided eye. So, technically, you can count them, but I wouldn't be surprised if you lost count. And if you're worried about flying through an asteroid belt, don't be. Although it does have trillions of space rocks that range in size from space dust to a quarter of the size of the Moon, they're very spread out. The asteroid belt between Mars and Jupiter is 140 million miles across, which is 1.5 times the distance between Earth and the Sun. This spreads space rocks thousands of miles apart, making it almost impossible for a spacecraft to collide with one. You'll instantly freeze in space without a suit. Nope, you won't turn into a popsicle right away. It's gonna take a bit longer than that because heat and cold don't really move very quickly in the vacuum of space. But unfortunately for you, there's a bigger problem at hand. You won't be able to breathe. After just 15 seconds, your brain won't be getting enough oxygen from your blood, and you'll pass out. And then after just 2 minutes, it's curtains for the rest of your organs. So, in short, if you find yourself playing astronaut without a spacesuit, it's game over pretty quickly. Did you know that space doesn't have any temperature at all? That's because the temperature is defined by the speed at which particles move and the amount of energy they have. In the true vacuum of space, there are no particles to move around, making it temperatureless. Of course, some parts of space are really hot, like areas around stars. But the further away you get from stars, the more spread out particles are, making those areas of space pretty chilly. Number 9 is our planet's shape. No, it's not flat, but it's not a perfect sphere either. Yeah, it bulges at the equator because of our planet's wild spin. It's like Earth is doing its own little dance. And because of this bulging, launching spaceships from the equator is much easier than from the poles. Now, when it comes to sound in space, it's a bit of a tricky situation. You might think that no one can hear you scream, but that's not entirely accurate. The thing is, sound needs something to travel through, like air or water. In space, things are super spread out, so all those epic space battles and galactic explosions would be completely silent. Yet there are some places in space with enough particles for sound to travel through. For example, you can hear the black hole at the center of the Perseus galaxy cluster. Another myth is about zero gravity. That's not a thing. There's still some gravity hanging around the International Space Station, about 90% of what we feel on good old Earth. But astronauts get to float around because they're basically free-falling around the planet. And let's be real, Hollywood's version of space travel is not factual. Sure, orbits are a thing, but different altitudes mean different speeds. So moving from one orbit to another isn't exactly a walk in the park. You can't just push yourself in the right direction and hope for the best. You gotta take those orbital velocities into account. This reminded me of the 2013 movie Gravity and how Sandra Bullock tried to survive in space. Hollywood sure added some fuel to these myths. Yet again, who can blame them? Back in 1976, NASA's Viking 1 spacecraft snapped a photo of a curious rock formation on Mars that looked suspiciously like a face. Some folks out there claimed that it must have been proof of extraterrestrial life on the red planet, but NASA had a different take. According to the space agency, the face was nothing more than a bunch of rocks piled up in such a way that the shadows they cast created an illusion of facial features. It turns out it was just a regular hill that got a little too much credit for being photogenic. The solar system stays in place. Lie! It's zooming through space at a speed of 140 miles per second, which means that it's whizzing through the cosmos faster than a cheetah chasing its prey. It takes us 230 million years for the solar system to complete a full orbit around the Milky Way. It's a good thing it isn't getting a speeding ticket, because that would be one astronomical fine. Eh? Without the sun, planets would be pretty chilly. We're talking about temperatures as low as -455 degrees Fahrenheit. Brrr. But with the sun around, the planets get to enjoy much more livable temperatures. Of course, not all planets are created equal. Mercury, for example, is the closest to the sun. Venus, on the other hand, is farther away, but somehow manages to be even hotter than Mercury. The distance from the sun isn't the only factor that affects a planet's temperature. Other things like the planet's size and reflectivity also come into play. So Mercury being the hottest planet in our solar system is a false proposition. No, just because it's the closest one to the sun doesn't mean it's the hottest. Even though we've been deceived in some ways, that doesn't make space any less amazing. It's still a vast, beautiful, and utterly fascinating part of our universe. And there's still so much we have yet to discover. Who knows? Maybe one day we'll really discover little green people out there. Or maybe we'll find out something even more incredible. Until then, we'll just have to keep dreaming and exploring. There, you got 14 things on our list. Do you have any other space myths to debunk? Hey MythBusters! Today we're debunking some classic space myths. Hop on the next space shuttle and let's get to the bottom of these tales once and for all. Picture this. You're floating weightlessly in space, sipping on a cup of delicious hot chocolate, when a peculiar thought pops into your head. Can you scream in outer space? And if yes, would anyone hear that scream?
If you've watched the movie Alien, then you know the answer to this one. You can't hear sounds in outer space.
It's not that sounds don't exist.
It's just that you can't hear them.
There's no one better to clarify this myth than Chris Hadfield. He's been on a couple of spacewalks during his life as an astronaut. And once you're out there in the darkness of space, you can't hear anything.
All you hear is silence. Complete silence.
But hey, just around the corner is a massive ball of explosion, aka the sun. We just can't hear the explosions happening because there's no medium for sound to travel through. It would be quite uncomfortable for an astronaut, though, if they could hear all the noises going on in outer space. Now, imagine you're zipping through space, feeling like a futuristic superhero, when a shooting star passes by your side. But wait, is it really a star? Unfortunately, shooting stars are not stars at all. They are small space rocks known as meteoroids, entering Earth's atmosphere and creating a stunning light show. Oh, and since we're debunking myths, let's head straight for another one. You've probably heard that meteors only crash into Earth on extremely rare occasions, like once every dinosaur extinguishing apocalypse. That's not true. Scientists estimate that about 48 tons of meteoritic material fall on Earth each day. But almost all of this material is vaporized in Earth's atmosphere. The bright trail we see in the night sky is what we popularly call a shooting star. Next time you make a wish upon a shooting star, remember, you're actually hoping on a tiny piece of space debris. It's not so romantic after all. Can we or can we not fly into the stratosphere on air balloons? Apparently, we can. The Earth's stratosphere starts relatively close to the ground, about 7 or 8 miles up from the Earth's surface, but it continues a long way up. If you were to fly yourself all the way into the stratosphere with some type of air balloon, just make sure you have really good equipment at hand. You'll need a special suit and some breathing devices because air starts to get pretty thin the higher you get. Of course, if you do go all the way up, you need to get a picture of the Earth's curvature. So take a chest harness with you where you can put a special camera or something like that. And how about you live stream the whole thing? That would be a first! Imagine it's been 102 days since you left Earth. You've adapted well to life in outer space, but something weird is happening to your body. You're getting taller. How is that even possible? Don't stress about it, it's completely normal. The truth of the matter is, you're not getting taller. This is what happens to your body when it's not under the effect of gravity. Our body has natural space between vertebrae and joints. On Earth, this space is almost completely squeezed due to the force of gravity. But in space, your body gets some time off of the pushing force of gravity and begins to stretch more and more. So yes, astronauts can grow up to 3% taller when they're on long missions. And here's a curiosity. NASA has that all covered when they're tailor-making spacesuits, of course. This way, astronauts will always have extra space in their suits. Once astronauts are back on Earth, the anti-gravity effect will wear off. So maybe they'll spend a few days wearing capri pants before it fits perfectly on their bodies again. Never have I ever pictured an airplane door bursting open mid-flight and a bunch of passengers being sucked into the atmosphere like flying feathers. Well, I'm betting most of you have had similar thoughts when getting inside a plane. Now imagine if this were to happen in outer space. Common knowledge says that if an astronaut is sucked out of an airlock, this person would be burnt to a crisp. Brace yourselves, because this is not only true, but the reality of it is way worse. According to astronaut Chris Hadfield, this is what would happen. The part of your body in the shade of the sun would experience temperatures of negative 418 degrees Fahrenheit, while the part of you getting sunlight would burn at around 480 degrees Fahrenheit. Your lungs would collapse, and your blood would start to boil like tea water. So you would burn, freeze, lose your ability to breathe, and boil. Yikes! How many times have you heard that astronauts have to work out every second of every day, otherwise they'll pass out? This is a complete myth. Remember we talked about gravity earlier? Due to the lack of gravity in outer space, our bodies don't have to do any heavy work. Our torsos don't have to sustain the weight of our heads. And we don't have to make any effort to move our legs because, essentially, there's no walking in outer space. Now imagine living like that for 6 months, or even a year of your life. Your muscles could turn into jello. That's why astronauts work out. They'll strap themselves and run on a treadmill, or they'll do some weightlifting in a special machine. This way, their muscles won't feel the lack of gravity too much. They do need to keep hydrated though. You know what? If I was an astronaut, I'd ask NASA if I could take my super soft water flask up into space with me. You've probably heard that space smells like burnt steak or barbecue sauce. Now, as much as this sounds absurd, this myth is more true than it is false. Astronauts obviously can't smell space when they're in it because they can't take off their helmets. They usually smell it once a space vehicle docks and they open up a hatch. Apparently, what causes this smell is the presence of hydrocarbons that float around in space. Who would have thought, huh? Hey, smart people, let me ask you a question. Do you really think that if astronauts fly at the speed of light, they won't age a single second? I knew you'd say no. Let's get a few things straight. First of all, we haven't figured out how to operate vehicles at the speed of light. This would require an immense amount of energy, and we don't have the technology to do that. Second, even if we managed to send a human inside a spacecraft that traveled at the speed of light, this person would still age. They would age differently than the people who remained on Earth, that's a fact, but they would still age. Do you lot really think there's such a thing as immortality? Nah. If you've seen the first Avatar, then you certainly remember that humans only managed to get to Pandora because they traveled in cryosleep. In other words, they froze their bodies, put them in a cryobed, and traveled for years without aging. Yes, this sounds amazing, but we still don't have the technology to do that. Our bodies are mainly made out of water, right? And when you freeze water, it expands. That's why you should never leave soda cans unattended in your freezer. Right now, if we froze a person's body, the water inside of it would expand, harming tissues and organs. So no, we can't cryosleep our way into interstellar travel. Not yet, at least. Here's a crazy thought. What would happen if an astronaut took a drone with him on one of their spacewalks? Unless it's a NASA-designed drone, maybe the thing would freeze and burn like humans would if they went into space without a suit. But hey, a person can dream, can't they?
No one will hear your cry in space, or something like that. We've all heard this famous chilling phrase, and it's actually true. Space, for the most part, consists of a giant nothingness. There's a lot of, space in space. But this doesn't mean there are no sounds in space. In fact, there are plenty of them, and some of them can even make you shiver. Let's take a look at the scariest space sounds. First of all, how are cosmic sounds even recorded? Sound is just the vibration of molecules. When you scream, you make the molecules push each other furiously until they reach the ear of the person you're yelling at. Then these vibrations get transmitted to the brain, and we recognize them as something that you might need to apologize for. In other words, to hear something, we need molecules. And that's where things get complicated. There aren't any of them in space. The entire universe almost completely consists of a vacuum. No, not a Hoover. Absolute nothingness. However, the wizards from NASA still record space sound somehow. So how do they do it? The thing is, there are some types of waves that don't care about molecules. We regular folk can't perceive them without some special devices. These waves include, for example, radio waves. We'll need a radio or something like that to recognize them. And that's exactly what NASA's satellites do. They catch random radio waves. Thanks to their heroism, we can find out how different cosmic bodies sound. These satellites record a variety of waves, fluctuations of plasmas, magnetic fields, and other, stuff. And then scientists from NASA transform all this into normal soundtracks. And some of them sound quite frightening, to put it mildly. Let's take our magnetic field, for example. It surrounds our planet like an invisible shield, protecting us from all sorts of nasties, like radiation and solar winds. At the same time, we can neither see it, feel it, nor hear. Oops. Well, the last one is outdated. Scientists from the Technical University of Denmark took magnetic waves recorded by the ESA swarm satellite. They converted them into an audio track and got a pretty creepy result. Now, to be honest, it sounds more like an eerie entity stalking you in the middle of the night. And if you remember the maps of Earth's magnetic field, it starts to feel like a spider crawling nearby. Ew. And this isn't the first strange sound that we caught on Earth. Recently, we caught another weird radio emission from space. Scientists found out that the repeating signal came from somewhere very far away, like billions of light years away from us. Such fast radio bursts usually lasted no longer than a few milliseconds, but this one was unique. It lasted about 3 seconds, basically thousands of times longer than usual. And at the same time, the signal was very precise, so much so that scientists even compared it to a heartbeat. Scientists believe that this signal is caused by pulsars, or neutron stars. One time, Nikola Tesla caught something similar, but unfortunately, at that time, we didn't know about such things as pulsars, so Tesla was sure that he had caught a message from some extraterrestrial life. It's a pity that the truth turned out to be much more boring. But let's move on from the Earth to the Moon. In 1969, the astronauts of the Apollo 10 mission, the spacecraft that made the final test flight to the Moon, flew past its surface. And then they caught some strange signals coming from the dark side of the Moon, the side that we never see because the Moon is tidally locked to us. The sound was so weird that the astronauts weren't even sure whether to report it to NASA. They were afraid they wouldn't be taken seriously, and maybe even not allowed to participate in the next space missions. Here's what it sounded like. But according to NASA, it's not some creepy extraterrestrial music at all. These may just be some radio waves that affected each other because of their proximity, although the astronauts who heard it for the first time probably felt a little creeped out. Let's move to the other planets. Now, 40 years ago, scientists actively explored the surface of Venus. They sent as many as 10 probes there, which were supposed to capture audio and video shooting from the surface. Now we know what Venus, which could easily destroy us at any attempt to even get close to it, sounds like. Horrifying. And you wouldn't expect anything else from the most dangerous planet in the solar system. Unfortunately, Venus is even more toxic than the average Twitter user. So these probes didn't last too long. They heroically arrived on a planet and soon broke down. Next one is Jupiter. This space giant, which is 11 times larger than the Earth, never fails to scare us. One of NASA's probes, Juno, flies around Jupiter every few weeks. The probe is moving at a tremendous speed, 130,000 miles per hour. One day, Juno caught one of the strongest invisible signals it had ever encountered. This was the point at which the mad solar wind came into conflict with the magnetic field of Jupiter. It kind of sounded like a cosmic boom. The original sound lasted 2 hours, but it was compressed to a few seconds. It actually sounds more like a collision of a sea wave and a rock. But here, in terms of horror, Jupiter surprisingly loses to one of its small moons, Ganymede. In 2021, the Galileo space probe flew past Ganymede, and during its flight, it received a rather strange recording. These sounds are satellite radiation, and it's unclear whether it sounds like a cozy sunny day in the jungle or like thousands of bats waiting for you in the night. Next one is Saturn. This signal was caught by the Cassini-Huygens Automatic Interplanetary Station, which was launched into space in 1997. When flying past Saturn, Cassini recorded a pretty scary sound. This terrifying cry of thousands of souls is actually just some radio waves. They aren't too different from what the auroras emit on Earth. A little later, Cassini received another recording, the sounds made by lightning and thunderstorms on Saturn. They sound pretty interesting, too. More like popping corn or a Geiger counter, right? But that's just because these lightning strikes have a crazy frequency. Moving on from the solar system to outer space. The famous Voyager 1 was launched back in 1977 and continues to send us data even 40 years after its launch. In 2012, it left the solar system and entered interstellar space. And then, while abandoning its home, Voyager 1 detected the sound of plasma waves. The original recording lasted 7 months, but fortunately, scientists felt sorry for us and reduced it to 12 seconds. It isn't really eerie, but is still kind of unsettling. And although it feels like nothing can beat Saturn's horrors, let's end this tournament with one of the scariest objects in the universe, a black hole. This sound was recorded by the Chandra Space Telescope. While studying a cluster of galaxies in the constellation Perseus, they discovered something strange. Some undulating movements appear from the center of the cluster. They spread out in all directions, like circles on the water. Scientists have suggested that this was caused by a supermassive black hole. The thing is, black holes don't always devour space objects entirely. Sometimes they kind of spit them out. This causes vibrations of gases, which we can convert into soundtracks. What's interesting is that the oscillation of each such wave actually lasts about 10 million years. You're just listening to a very accelerated recording. Scientists have reduced the delay between oscillations by about 144 quadrillion times. So let's check it out. This is probably the eeriest sound from the whole list. Nothing too loud or wild, but there's something dark and disturbing about it. Now, those were the scariest space sounds captured by NASA. To be fair, most of them sounded creepy simply because they're radio waves, but it's still fun to get spooked sometimes. Our Sun is an average-sized star, and still, it could fit 1,300,000 Earths. The star is also 333,000 times as heavy as our planet. NASA has translated radio waves created by planets' atmospheres into audible sounds. That's how astronomers found out that Neptune sounds like ocean waves, Jupiter like being underwater, and Saturn's voice resembles background music to a horror movie. Here on Earth, it's bebop jazz. No, I made that up. The sun's surface is scorching hot, but a bolt of lightning is 5 times hotter. Earth gets struck by 100 lightning bolts every second, which results in 8 million lightning strikes a day and around 3 billion a year. Ooh, shocking. If you manage to go to the moon one day and see fresh footprints, that doesn't mean there's someone else there with you. Footprints or similar marks can last for 1 million years over there. Because the moon doesn't have an atmosphere. There are no winds, not even a breeze, that can slowly erase those footprints. Astronomers have found the largest hole we've ever seen in the universe. It's the giant void that spreads 1 billion light-years across. They found it accidentally. One of the research team members was a little bored and wanted to check how things are going in the direction of the cold spot. That's an anomaly in the Cosmic Microwave Background Map, or CMB for short. It's a faint glow of light that falls on our planet from different directions and fills the universe. It's been streaming through space for almost 14 billion years as the afterglow that occurred after the Big Bang. So, you fall right into the heart of the black hole and prepare for a sad end. Well, you don't have to. Falling into a black hole won't necessarily destroy you or your spaceship. You have to choose a bigger black hole to survive. If you fall into a small black hole, its event horizon is too narrow, and the gravity increases every inch down. So, if you extend your arm forward, the gravity on your fingers is much stronger than on your elbow. This will make your hand lengthen, and you'll feel some discomfort. Rather significant, to be honest. Things change if you fall into a supermassive black hole, like the ones in the center of galaxies. They can be millions of times heavier than the Sun. Their event horizon is wide, and the gravity doesn't change as quickly. So, the force you'll feel at your heels and at the top of your head will be about the same. And you can go all the way to the heart of the black hole. This myth is busted. If you watch a very touching movie in space and start crying, your tears won't run down. They will gather around the eyeballs. Your eyes will get too dry, so you'll feel like they're burning. Any exposed liquid on your body will vaporize, including the surfaces of your tongue. Speaking of burning, that's one thing fire can't do in space. Fire can spread when there's a flow of oxygen, and since there's not any in space, well. Once they explode, stars aren't supposed to come back to life. But some of the stars somehow has survived the great supernova explosion. Such zombie stars are pretty rare. Scientists found a really big one called LP 40-365. It's a partially burnt white dwarf. A white dwarf is a star that burned up all of the hydrogen, and that hydrogen was previously its nuclear fuel. In this case, the final explosion was maybe weaker than it usually is, not powerful enough to destroy the entire star. It's like a star wanted to explode but didn't make it, which is why part of the matter still survived. If you ever go into space, don't take off your spacesuit unless you're on a spaceship. Air in your lungs would expand, as well as the oxygen in the rest of your body. You'd be like a balloon, twice your regular size. Good news, the skin is elastic enough to hold you together, which means you wouldn't explode. Small comfort. When something goes into a black hole, it changes shape and gets stretched out just like spaghetti. This happens because gravitational force is trying to stretch an object in one direction, but at the same time squeeze it into another, like a pasta paradox. Speaking of, a black hole that's as big as a single atom has the mass of a really big mountain. There's one at the center of the Milky Way called Sagittarius A. It has a mass like for 1 billion suns, but luckily it's far away from us. If you made a big boom on an asteroid, you'd never be able to hear its loud sound. Yes, we often hear the sound of spaceships and battles in space in the movies, but that's just a myth. Sound is a wave that spreads because of the vibrations of molecules. A person claps a few feet away from you, the sound wave begins to push the first air molecule next to the clap, then the second, third, and so on, until the wave reaches your ear. So, to spread sound, we need molecules like air or water. In our atmosphere, sound waves spread out just fine, but space is a vacuum, so it's nothing here. You can clap your hands loudly there, but there just won't be any molecules that can vibrate and carry that sound. So, to carry on a conversation, you'd either need a radio or really good lip-reading skills. Meteoroids orbit the Sun, while the majority of human-made debris orbits our planet. For example, we launched almost 9,000 spacecraft around the world from satellites to rocket ships. Even the tiniest pieces can damage a spacecraft at such high speeds. Galaxies, planets, comets, asteroids, stars, space bodies are things we can actually see in space. But they make up less than 5% of the total universe. Dark matter, one of the biggest mysteries in space, is the name we use for all the mass in the universe that's still invisible to us. And there's a lot of it. It may even make 25% of the universe. Dark energy makes the other 70% of the universe. That adds up to 100, right? Now, let's look at the moon. It always looks at us with one side. This means the moon has a dark side and the sun's rays never get there. Well, that's a myth. The whole point is that the moon is gravitationally locked to the Earth. There are days and nights there too. It's just that this rotation is perfectly aligned with the rotation of the Earth. So whenever you look at the moon, you only see one side. Although there are days when the sun shines there too, so it's not the dark side, it's the far side. And we even have pictures of this place. And there's one of the biggest craters in our entire solar system, the South Pole Aitken Basin. It's as wide as 2 states of Texas. Yeehaw! One myth that turned out to be untrue is that people have never actually been on the moon. This is the original spacesuit of the first astronauts who were there. Look at the sole of the shoe. Some people claim there's no way they could have left footprints like this there. Actually, they could. On the moon, the astronauts wore extra boots over their suits, and their soles matched the footprints on the moon perfectly. Now, the astronauts didn't need them when they left the moon and tossed them when the moonwalk was over. They left a lot of stuff there, too. They even tossed the armrests of the seats in the lunar module to reduce the weight. Now, counting all the Apollo lunar missions, the total weight of rubbish on the moon is approximately 187 tons, including several lunar rovers, spacecraft debris, 6 lunar modules, and all the experiments left behind. That's like 3 Boeing 737s. Another myth about the sun is that it's yellow. Let's send you into space for this one. You look out the window and it's white. The sun only appears yellow to us through the filter of our atmosphere. The composition of the air and its thickness just distorts the light of the star. But stars do come in different colors. Cooler stars have bright orange and red colors. These are usually very old stars, older than our sun. But young and very hot stars are bright blue. The sun is about in the middle of this spectrum. Oh, one more myth about asteroids. We need to fly a little farther than Mars's orbit. Whoa, we're in an asteroid belt, and we constantly have to dodge giant rocks and blocks of ice. We got in some dense asteroid clouds. Not true. The fact is that space is huge, and the distances are incredible. All the rocks and debris in the asteroid belt are only 4% of the weight of the moon, so there really aren't that many of them there. To understand the dimension of the emptiness in space, look at the collision of 2 galaxies. There are billions of stars in each of them. If we mix them up, it's unlikely there will be any collisions even here.
Imagine a basketball spinning on someone's finger. A point near the middle of the ball takes longer to spin back to where it started than the spot where your finger is. Earth spins in much the same way. People in the center of Africa are turning at 1,000 miles per hour as the planet rotates, while anyone at the South Pole doesn't really move at all, other than rotating in place. At the same time, we're all moving forward through space equally fast, since the planet is also hurtling around the sun at 67,000 miles per hour. The temperature at the boundary of our planet's inner and outer core is 10,800 degrees Fahrenheit. That's as hot as the surface of the sun. And the pressure there is 3.3 million times the atmospheric pressure at sea level. 2 or 3 years ago, an asteroid was pulled into Earth's orbit and started to travel around the planet. Even though it's no larger than an average car, it's still a big deal. Out of more than 1 million asteroids astronomers know about, it's only the second one to orbit our planet. Called 2020 CD3, it's our temporary mini-moon. It won't be with Earth for long though. The asteroid is following a random orbit and is slowly drifting away. Temporarily captured objects, such as 2020 CD3, are rare. They need to have a specific direction and speed to be caught by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction. The movement of galaxies and clusters billions of light years away from us suggests there's some enormously massive body outside the visible universe. After billions of years, the expansion of the universe will make the space so sparse that we won't be able to see the stars in the sky at all. The moon isn't a perfect sphere. It's shaped like an egg. Plus, the satellite's center of mass is a bit more than a mile off its geometric center. Even though Venus is the hottest planet in our solar system, it still has snow. But not what you'd expect. It snows metals and rains acid. Not a great vacation spot. Saturn is mostly composed of hydrogen and helium, with some traces of methane, ammonia, and water. But it contains more sulfur than Jupiter, which gives the planet a smog-like orange hue. On Earth, sound waves make air molecules vibrate, which is why we're able to hear sound. Other planets and moons allow sound to travel through mediums like their atmospheres and oceans too. In space, though, it's said that there is no sound, since there aren't any molecules to vibrate and deliver sound waves. However, not all researchers agree on this, given that space isn't just a desolate vacuum. In between the emptiness, there are clouds of gas and other stray particles. So, depending on where you are, sound waves can be possible. Astronomers know for sure that the universe is growing bigger, and the speed at which it's ballooning is increasing all the time. But if the whole thing is swelling into something bigger, then it must have some kind of an edge, right? It's unlikely that people will ever find out, but if so, then what would it be? A ginormous brick wall and then nothing? An abyss that leads to nowhere? The most common theory is that the universe is shaped in such a way that it can't have an edge, but it's not the only idea. Another theory is even more difficult to comprehend. The universe is, indeed, infinite, and our part of it isn't that unique. It means that somewhere out there, there's another you, or rather, other you. One of them is just a bit shorter, another wears their hair in a different way, and the third one is identical to you in all possible ways. There's also a theory about a multi-universe that consists of many smaller universes, and the universe we live in is just a tiny bubble among other similar bubbles. Those scientists who support this idea are also sure that bubble universes can come into contact with one another. Then gravity starts to flow between them, and when 2 or 3 universes connect, a big bang occurs, just like the one that created our home universe. Neptune is the windiest place in the solar system. Clouds of frozen methane are whipped across the planet at a speed of 1,200 miles per hour. Neptune's core is solid and consists mostly of iron and some other metals. Its mass is 1.2 times bigger than that of Earth. The temperature inside reaches 9,000 degrees Fahrenheit. Astronomers also believe that at a depth of 4,500 miles, there might be a diamond layer where it's raining diamond crystals. On Earth, people are used to a beautiful sunset that's painted in hues of orange, red, and yellow. On Mars, however, the normally pinkish red sky turns blue as the sun goes down under the horizon. It's because Mars is much farther away from the sun than Earth, making the sunlight less intense. The fine dust in the Martian atmosphere absorbs the blue light and gets rid of the warmer colors that you typically see on Earth. Whether it's blue or yellow, both sunsets look spectacular. At around a quarter of the size of Earth, the Moon is pretty enormous relative to other satellites out in space. There's nothing quite like this situation anywhere else in the solar system. Pluto has a moon that's almost half as big as itself, but it's more like a twin than a satellite. There are more than 150 moons in our solar system, and Earth's is the 5th largest out of the whole lot. There might be a labyrinth of lava tubes on the moon. Not long ago, astronomers received the results of an underground lunar topography. They discovered a massive cave under the satellite's surface. About 30 miles long and 60 miles wide, the cave's likely to be the result of 3 billion-year-old volcanic activity. After streams of lava hardened, they created a thick, hard crust on the outside. But inside, lava kept flowing, melting the rock and forming tunnels and caves. Countless pits in the moon's surface discovered by NASA might be the openings to lava tubes. We can't dig up most of Earth's gold. 99% of it ended up in the center of the planet several billion years ago, attracted by the iron in Earth's core. We're talking about 1.6 quadrillion tons of gold here. That's enough to coat the entire planet's surface in 1.5 feet of the stuff. And if all those meteorites hadn't later smashed into the ground, bringing extra amounts of gold, it would be even rarer. Not so long ago, astronomers discovered a massive blob of some mysterious substance. It was hidden underneath the surface of the moon's far side. Its mass was the same as that of a pile of metal 5 times larger than the big island of Hawaii. The enigmatic something lies almost 200 miles beneath an enormous crater that appeared on the lunar surface billions of years ago. The blob likely has something to do with a super collision. It might be the metal core of the object that hit the moon back then. Scientists can't wait to lay their hands on the discovery. It could explain lots of things about the South Pole Aitken crater, the largest known in the solar system. If it was on Earth, its oval-shaped basin would stretch from Washington, D.C. to Texas. In 2011, astronomers discovered an enormous water reservoir simply floating in space around a supermassive black hole called a quasar. Floating water vapors have been found throughout the universe, but they aren't that common. This particular reservoir holds around 140 trillion times the amount of water in the Earth's oceans. It's one of the oldest, largest, and, at more than 12 billion light-years away, one of the farthest things known to humankind. Astronauts in space can lose about 1% of their muscle mass each month. To prevent this, they have to stick to an exercise regimen that lasts 2 hours every single day. The Milky Way galaxy and the Andromeda galaxy are going to meet in 3.75 billion years. They're moving toward each other at a breakneck speed. When the two galaxies collide, they'll form a huge elliptical galaxy. I won't be around then. Have you ever looked up at the night sky and tried to count all the stars? Yeah, good luck. Our galaxy, the Milky Way, has about 100 billion stars, but other estimates put it at over 200 billion, since calculating the exact amount is an almost impossible task, even for astronomers. As for the entire universe, there are at least 1 billion trillion stars. That's one with 21 zeros after it. For comparison, that means there are more stars in space than there are grains of sand on all of the Earth's beaches.
All aboard! This is the Intergalactic Cruiser. The destination on your ticket is a tour of the local group of galaxies, featuring the large and small Magellanic galaxies, the Orion Nebula, the Andromeda and Triangulum galaxies, and a few surprises in between. Tickets, please. Be advised you may experience a slight tingling sensation as we rev into hyperspace. The ship and everything in it is going through a dimensional phase change. It's nothing to worry about. The tingling passes quickly. Now, passengers, as we head toward galactic latitude 180 degrees north, as Terrarians are accustomed to calling it, our first main item of interest will be an intense star-forming region known as M42, the Orion Nebula. But first, a special treat by the captain that's not on the advertised itinerary. The Horsehead Nebula. It's off to the port side. That's left for you Aggies. Its designation is M43. The newborn star at the top of the Horse's Head has a strong solar wind that is deforming the shape of the nebular cloud. Get a good look at it now, because in a few thousand years, those gases will be completely blown away by the star-like nebula that made our sun. Yep, long gone, except for the nebular gases captured by Jupiter, Saturn, Uranus, and Neptune. Okay now, one of our junior explorers asks a question. What is the M in M42 and M43? Well, young lady, the M stands for Messier. Pronounced Messier, not Messier, as in, is your room messier than mine? Charles Messier to be precise, was a French astronomer in the 18th century. He published a catalog of 110 fuzzy objects as seen through an early telescope. The Horsehead Nebula is number 43 on his list. We'll see more M's as we continue our tour. Heads up, we're coming to the Orion Nebula. The gases in the nebula may seem less colorful than you expect. That's because we're accustomed to seeing long-exposure telescopic photos and enhanced photos designed to highlight the different gases in the nebula. May I suggest using the pair of tinted glasses that come with your onboarding packet if you want to heighten your experience. In we go! Now, it's a good thing we are in hyperspace. As we approach the trapezium star cluster in the center, the bright star, Theta C, sends out a solar wind at 5 million miles an hour. It sculpts the whole cloud of gas and dust, creating shock waves that compress nearby stars. Theta C is a megastar, 200,000 times brighter than the Sun. It will go supernova in about 1 million years. I won't be around then. Oxygen, hydrogen, and sulfur glow in ionized states like a fluorescent light bulb. Oxygen blue, hydrogen red, some green and sulfur, and dust glow as yellow-orange. As we pull out of the Orion Nebula and rise high above the galactic plane, the spiral arms of the Milky Way are visible. Our sun, which you cannot distinguish from this height above the galaxy, is in the Orion Spur that lies between the outer Perseus arm and the inner Sagittarius arm. Notice the center of the Milky Way contains a bright magnetic bar that plays an essential part in star formation. Over 70% of nearby galaxies include magnetic bars. It's a sign of a mature galaxy. Only 20% of distant galaxies contain magnetic bars in their cores. Which reminds me, passengers, the juice bar is now open. Our H1 server will take your orders. Now, that's the Andromeda Galaxy far, far out to the port side. But may I call your attention to the many dwarf galaxies, over 40 of them, that populate our galactic neighborhood. We're heading to one now. The Large Magellanic Cloud, LMC to astronomers, is an irregular dwarf satellite galaxy of the Milky Way, containing about 30 billion stars with a dynamic star-forming region called the Tarantula Nebula, which we will be cruising through shortly. Of course, if there is a large Magellanic Cloud, there must be a small Magellanic Cloud, SMC. And there it is, below and to the left of the LMC. The Milky Way will eventually ingest both dwarf galaxies. Some prefer the word accreted, but the result is the same. If you use your tinted glasses again, you can see that the LMC has stripped away a tremendous amount of gas from the SMC, as they have interacted gravitationally over millions of years. Hey, I know all about gas. Now we're heading out of the Milky Way to a distance of about 50 kiloparsecs. That's 50,000 parsecs, or about 163,000 light years. So, what's a parsec? No, it's not slang for pair of socks. A parsec is about 3.26 light years. A light year is about 5.88 trillion miles. The word parsec is a combination of two words, parallax and second. Parallax is the shift an object seems to make when viewed from two different perspectives. Looking at an object with your left eye and then your right eye, you'll see the object appear to shift. That's parallax. When an astronomical object is photographed with the Earth on one side of the Sun, and then again 6 months later on the other side of the Sun, the shift is measurable in degrees of arc, or minutes of arc, or seconds of arc, down to milliseconds of arc. That's a parsec, a parallax of 1 arc second, which turns out to be 3.26 light years. Hey, what about a Joan of Arc? That's how you measure distances in France. Ha ha! Meanwhile, since you can't measure a light year with a ruler or a tape measure, parsecs are the scientific way of telling the distance to a star or intergalactic object. The greater the parallax, the closer the object is. The smaller the parallax, the farther away it is. Now, straight ahead in the heart of the Tarantula Nebula is the R136 star cluster. Within a distance of 1 light year, there are over 40 stars each with a mass over 50 times that of the Sun. Wow! Comparatively, there isn't a single other star within 4 light years of our home star, Sol, and that's a good thing. You can see supernova 1987A at about 2 o'clock high. a blue giant star 100,000 times brighter than the Sun experienced a core implosion, resulting in a Type II supernova 100 million times brighter than the Sun. It has left behind a neutron star, clouded in dust and gas, and a wildly spectacular display of fireworks. Now, 1987A in the Large Magellanic Cloud is the closest supernova to Earth since 1604, which happened in the Milky Way about 20,000 light-years from Earth. It was visible in the daytime for about 2 weeks, or so. After 1987A went supernova because it was a blue giant star, speculation has increased that the blue giant star Rigel, the foot star of the constellation Orion, might go supernova in the not-too-distant future, or already has gone supernova. Rigel is approximately 860 light-years from Earth, so anything that happens to Rigel would take about 860 years before it would be noticed on Earth. Supernova 1987A ejected the heavy elements like cobalt, nickel, and iron and lighter silicates into the Tarantula Nebula, where they will form the basic building blocks of stars and planets. Our server is now offering space-themed snacks. May I recommend the Jupiter Cotton Candy Puffs for the children on board? Remember, I know all about gas. Our next stop is the Andromeda Galaxy and environs. Notice its halo as we leave the Milky Way and its 300 billion stars behind. As many as 150 globular clusters reside in the galactic halo. They orbit down and through the galactic disk and contain some of the oldest stars in the universe. How they got here in our home galaxy is a matter of intense study. You will notice NGC 6822, an irregular dwarf galaxy off to the starboard. NGC stands for New General Catalog of Astronomical Objects. Now you'd think there'd have been an old general catalog, but there wasn't. It was just a new catalog. There is, however, a revised new general catalog which astronomers refer to regularly. Clears that up, huh? As we pass NGC 6822, you'll notice a magnetic bar beginning to form and bright patches of new star formation. This galaxy was discovered in 1884 by E. Barnard and is also called Barnard's Galaxy. Mr. Barnard was quite an astronomical observer. He has a crater on the moon named for him, one on Mars, an area on Jupiter's moon Ganymede, a minor planet, number 819 Bernardiana, and the star with the fastest movement across the sky, Bernard's Star. Now, not too many people have their name emblazoned across space, as has Edward Emerson Bernard. Approaching the giant Andromeda Galaxy with its trillion stars, we will skirt above its western edge and visit one of the enormous galaxy's dwarf companion galaxies, M110 or NGC 205. Yes, it also has 2 designations. Hey, take your pick. The first of its kind, a dwarf spheroidal galaxy of about 3.5 billion solar masses, M110 or NGC 205 if you wish, has 8 globular clusters near its core. It too will be swallowed, or accreted if you prefer, by the Andromeda Galaxy. It may have already been stripped of much of its stars and gas, a point highlighted by M110's general lack of star formation. Everybody having fun yet? And now, our final stop, M33, the Triangulum Galaxy, the third and last spiral galaxy of our local group. Located in the small constellation of Triangulum, Latin for triangle, good guess, M33 is about half the size of the Milky Way. The Triangulum Galaxy is 2.7 million light-years from Earth, but it is much closer to the Andromeda Galaxy and moving towards it. If 2 spiral galaxies collide, it may alter the course of the Andromeda Galaxy and prevent the predicted collision with the Milky Way. Well, let's hope so. Now, this important message. We will serve dinner on our return trip to Earth. There's a choice of chicken or fish. We hope you have enjoyed the tour. Hey, if you fill out our survey and give us 5 stars, you can also have dessert.
This is the final game of the year. Millions of viewers are glued to their TV screens. The 50,000 people in the stands of the stadium are holding their breath. Everyone's waiting to see who will win this game. It'll decide the winner this year. The loudest fans have stopped chanting. The air's become thick as syrup. It's so quiet, you can hear the heartbeats of the spectators. The pitcher looks at the ball one last time. He's taking wind speed into account and prepares to bring victory to his team. There's the throw! The ball flies like a bullet through the stadium, but the batter's reaction is perfect. And then, the incredible happens. The impact energy accelerates the ball to the speed of light. Okay, let's stop now. I've got to explain this. Nothing in the universe can reach the speed of light if it has mass. For a person, a car, a rocket, even a comet, that speed is out of reach. According to Einstein's general theory of relativity, when an object moves, its size decreases and its mass increases. If an airplane accelerated to the speed of light, its mass would be infinite and its length, 0. It's impossible. But living by the rules is boring, even if they're the laws of physics. I'm sure Einstein would love our idea. So, in our lawless world, the batter hit the ball and it flew at 186,000 miles per second. In just 1 second, the ball would fly around the Earth 7.5 times. Spectators, grass on the stadium, air molecules. Everything around is frozen. Only the ball is moving forward. The small projectile flies out of the stadium, rips apart the atmosphere, and goes into space. And then, the horror, the ball crashes into the International Space Station at full speed. The station has no chance. An object at the speed of light will blow away everything in its path. This story is impossible, not only because a baseball player's bat would break from such a blow. A small ball of leather and rubber will trigger a flash in the center of a stadium that is brighter than the sun. The bright light would be followed by a thermonuclear explosion. When the batter propels the ball to the speed of light, the show begins. The ball moves so fast that the air molecules don't have time to flow around it. The atoms in the air molecules hit the ball and mix with its atoms. Gamma rays appear. They break molecules apart. The air around the batter turns into red-hot plasma. The umpire and the catcher aren't to be envied either. Try to play baseball in volcanic lava. All this happens in nanoseconds. There's 1 billion nanoseconds in 1 second. The eyes and brains of people don't have time to analyze what's happening in front of them. The ball breaks into tiny pieces. Now it looks like a cloud of burning plasma. These are carbon, oxygen, nitrogen, and hydrogen. The stadium is engulfed in plasma and X-rays. For miles around, there's little more than a desert. The landscape resembles the surface of the moon or Mars. Let's take a look at it in slow motion. The bright light comes on first. Then a fireball appears in the middle of the stadium. Boom! The sound of the explosion reaches you. A pillar of fire bursts into the sky and turns into an eerie cloud that most resembles a colossal mushroom. Don't forget about the blast wave. It tears the trees out of the ground and knocks out all the windows in the vicinity. Thankfully, in the real world, such a situation is impossible. The International Space Station has enough problems without baseballs. Here's an American football field, and this is the ISS. The station weighs 420 tons. This is the largest spaceship ever built by humans. The large size and weight of 320 cars doesn't prevent the station from flying 5 miles per second. The ISS orbits the Earth 16 times per day. At this speed, any particle can pierce the hull of the ship or tear off one of its solar panels. There are 2,000 active satellites flying around the Earth. Another 3,000 don't work, but continue their space travel. And that's not all. In space, there are 100 million pieces of debris no larger than half an inch. And we sent them there. At least 34,000 particles the size of your smartphone and more. Even the smallest piece can destroy an astronaut's suit, equipment, or unprotected areas of the ISS. A single screw flying at 40 times the speed of a jet is a dangerous projectile, especially in space. Still, the ISS is safe. The padding protects it against impact with small objects. Now with larger ones, it's more difficult, but scientists have figured out how to deal with them too. a security perimeter has been created around the ISS. Imagine a pizza box 15.5 miles long and 2.5 miles wide. The space station is suspended in the center of the box, and its walls are the perimeter boundaries. NASA specialists record every violator of the space border. Scientists calculate the probability of collision. If it's dangerous, the ISS begins to maneuver and avoids the impact. In 2020, the station changed its flight route 3 times. Hundreds of objects enter the Earth's atmosphere every year. Most are burned before they hit the planet's surface. If the metal debris bursts through the atmosphere, it most likely end up in unpopulated lands or the ocean. Still, things happen. In the early morning of January 22, 1997, Lottie Williams was walking through a park in Oklahoma. In the pre-dawn sky, she saw a bright ball of fire. The woman decided it was a shooting star. Suddenly, she felt something touch her shoulder. It turned out to be a palm-sized piece of metal. The blow didn't harm Ms. Williams. She was the only person on the planet to have been hit by space debris. It was part of the fuel tank of the American Delta II rocket. The probability of getting hit by space debris is minimal. A huge kraken will sooner crawl into your room than a piece of a space satellite hitting you. Debris is invisible in the stream of thousands of small meteorites. They bombard the Earth's atmosphere every day. Most of the rocks are burned in it, and those that fall onto our planet are invisible. The only confirmed case of a close encounter with a meteorite was with Ann Hodges. In 1954, a space rock broke through the roof of a house and hit the woman in the thigh. The meteorite left a hole in the ceiling and a bruise on Ms. Hodges' leg. Let's imagine what would happen if an object the size and weight of a bowling ball flies toward our planet, naturally at the speed of light. In 2 seconds, our space object makes the distance from the moon to the Earth. The ball will crack, but we'll have time to start thermonuclear fusion. This process will release X-rays that will transform the atmosphere into a plasma bubble. It'll constantly expand. There will be no point of impact of space debris on the surface of the Earth. It won't have time to land, but it'll do a lot of nasty stuff. The explosion in the atmosphere will be colossal. The cataclysm will turn part of the planet into a lifeless desert and provoke the destruction of part of the Earth's crust. On the surface, fires, earthquakes, tsunamis, and volcanic eruptions will begin. The sun is the main source of light in our solar system. Light from the star reaches Pluto in 5 hours and 50 minutes. Mercury is only 3 minutes and 20 seconds away. As for Earth, 8 minutes and 20 seconds are enough. If we send a spacecraft to Mars tomorrow, it will reach its destination in 7 months. A rocket that travels at the speed of light will get it done in 3 minutes. We'll hardly ever learn to fly at the speed of light. Most modern spacecraft are powered by ion engines. But scientists are looking for an alternative. For thousands of years, people traveled by ships with sails. Today, this technology is relevant again. Engineers suggest using sails in space. They propose to catch the solar wind with them. A sail is installed on the spacecraft, and photons of light hit it. This creates pressure that pushes the object forward. The most ambiguous idea so far is to create an external pulsed plasma propulsion engine. Its principle is detonating hundreds of nuclear charges behind the spacecraft. The ship will fly forward on their shockwave. Thanks, but no thanks. The most sci-fi way to travel in space is to use a warp drive. In this case, we can fly faster than the speed of light. But first, we have to build an engine that distorts space-time and use this distortion for space travel. So far, this technology can only be found in movies and comics.
Picture this. You're an astronaut, hurtling through the cosmos in your state-of-the-art spaceship. But suddenly, you notice that you're running out of fuel. What are you going to do? Trapped in the middle of space. It's hardly like there's a floating gas station. The good news is that you're not going to get completely stuck. A spaceship will never actually stop after running out of fuel, all because there's basically no atmosphere in space. That's where the popular phrase, "in space, no one can hear you scream," comes from. Sound travels through the vibration of teeny tiny atoms and molecules. In space, where there is no air, there's simply no way for sound to travel. It's the same for our spaceship. Because there's no air, there's also a complete lack of air resistance. Those tiny particles that do exist in space are way too small to reduce the spacecraft's momentum or drag it back. Because of this, most spacecraft actually turn their engines off for the biggest part of their journey. So, don't believe those movies that show spaceships with their engines on all the time. That's completely inaccurate. Unlike vessels in the water, a ship in space doesn't need constant thrust to keep moving forward. Usually, its engine is only fired up for short periods of time. This is not only practical, but also saves money. Fuel is really expensive to transport into space as it's heavy. That's why space probes try to use as little fuel as possible. They need it when they set off from Earth, and then again when they re-enter the atmosphere. It happens when they need to slow down upon their return. While cars and trains have brakes, it's not that simple to bring a spaceship to a screeching halt. The engines are needed to slow the ship down or bring it to a complete stop. This involves strategically firing up impressive thrusters at the front. It creates the needed drag and reduces the spaceship's speed. But this process also requires super high levels of precision. One wrong move and you're toast. Literally. Hit the thrusters too fast and the spacecraft will set on fire as you re-enter Earth's atmosphere at thousands of miles per hour. Traveling too slowly can also cause problems, because in this case, you might miss our planet's orbit completely and move way past Earth. And most spacecraft don't have enough fuel to try for a second re-entry, so traveling too slowly needs to be avoided at all costs. But back to the issue at hand. This basically means that any vehicle with an empty tank will continue traveling at the same speed across space until it eventually runs into something. There's just no other way for it to stop. Wait, actually, maybe that's not good news. If you get stranded, it's pretty unlikely that your buddies over there at NASA are going to organize a rescue mission. This sounds kinda sad, but it does make sense. By the time they set up a new team and find a ship to come and rescue you, you'll have already traveled so far into space it would take them years to reach you. This would also cost a ridiculous amount of money. NASA spends on average a whopping $152 million to launch a ship into space. That's as much as buying 6 brand new top-of-the-range Lamborghinis. Even crazier, it cost NASA about $49 billion to develop and launch the first space shuttle. Unfortunately, once you've left Earth's orbit, it's near impossible that you'll make it back without fuel. That's what actually happened to NASA's Dawn spacecraft back in 2018. On a random day, the spaceship ran out of fuel. This left it completely stranded in the middle of space. It stopped transmitting signals to Earth, bringing an end to an 11-year-long mission that set loads of space records. The spacecraft could no longer generate electricity, as it had no fuel to move its solar panels to point them toward the sun. And to this day, the spaceship is still floating somewhere in space in a derelict state. Luckily, Dawn had no astronauts on board. The spacecraft began to orbit the Dwarf planet Ceres, which was the object it was originally investigating. For context, an orbit is a curved path around a star, planet, or moon that an object gets stuck in. But wait, NASA are experts in all things relating to spacecraft. So how did they allow a ship to run out of fuel in the first place? It's actually super difficult to accurately measure the amount of fuel you'll need in space. On Earth, gravity keeps all the fuel at the bottom of the tank, and you can use a float sensor to measure how full the tank is. But this is impossible in space due to a lack of gravity that normally weighs the fuel down. Instead, a common approach is to add an air bladder into the fuel tank that's pressurized before launch to push the fuel into lines. The more fuel is used, the more this bladder expands. It takes up more space and keeps the fuel under the right amount of pressure. This pressure is monitored. That's how they can tell how much fuel is left. As you see, it's a lot more complicated than here on Earth. But say there were astronauts aboard a spacecraft that had run out of fuel. How long could they survive? Well, this depends on how much food and water is on board. NASA usually calculates the extra amount of food astronauts need for their trip to avoid adding extra weight to the spacecraft. But the good news is that this food can technically be rationed, and its consumption can be spread out. That's because astronaut food comes in special packaging to stop it from going bad. There are no refrigerators aboard spacecraft. The food comes in clear, flexible pouches that can be snipped open with scissors. All the food is pre-cooked and processed, so it doesn't need to be stored in a fridge. The only exceptions are fresh fruit and vegetables. These are the only things that need to be eaten quickly, as they will spoil. Today, astronauts also work with nutritionists so they can pick out the foods that they like and will enjoy eating. They can choose from a whole bunch of products, including mushroom soup, macaroni and cheese, chicken, beef, ham, nuts, and even yummy cookies. Shrimp cocktail is apparently a new favorite among astronauts because of how spicy it tastes. Flavored drinks also come in powdered form, just like the Kool-Aid or instant coffee packets you have sitting in your kitchen cupboard. Interestingly, astronauts often report not feeling hungry in space, so it may be easier than you'd think to ration the food. But even if you can make your food last, what about water? Transporting anything into space costs a lot, and water is quite heavy, so it costs even more to transport. For this reason, tanks of water can't be constantly shipped up to space. Instead, astronauts have a really complex water system. It squeezes every last drop of safe and available liquid out of the environment. This involves recycling used water. It means that our buddies in space drink water that's been filtered from old shower water, their breath, the spaceship's fuel cells, sweat, and so on. But don't worry, such water is safe to drink, and it's actually even better than most drinking water that comes out of taps in the US. The water on a spacecraft first goes through a bunch of filters, starting with one that removes particles and debris. Then it passes through multi-filtration beds, containing clever substances that remove impurities. The final stage gets rid of harmful compounds and destroys nasty bacteria and viruses. There are also water reserves in case of emergency. For example, the International Space Station keeps around 530 gallons of water in its reserves, just in case. But what about the air supply? The primary source of oxygen on spacecraft comes from something called water electrolysis. This is an amazing system that uses electricity from the craft's solar panels to split water into hydrogen and oxygen gas. But as we saw with NASA's Dawn, without electricity, it's pretty difficult to aim the solar panels at the sun, which means that the oxygen system would likely shut down. There is some oxygen stored in a pressurized storage tank, though. This is a backup supply designed for emergencies, so it's not all bad news.
There are a lot of unanswered questions in physics. How did universal energy and matter appear? Where did gravity come from? And much more. We've been trying for years to get answers to these questions, and one of the people who tried to do this was Paramahamsa Tiwari, the author of the so-called space vortex theory. What is this theory, and what does it say about the hidden laws of our universe? Let's figure it out. Paramahamsa Tiwari was the former executive director of the Nuclear Power Corporation, India. He took the space vortex theory, or SVT for short, first proposed by René Descartes, and finalized it. He was always inspired by physics and its greats, even since his days as an electrical engineering student. After rigorous studies of the laws of physics, he discovered new equations defining matter and the mass and charge of the electron. After that, he came up with the SVT. This theory tried to explain the unexplained phenomena in physics, including the creation of the electron and gravitational, electrostatic, and electromagnetic energy fields, as well as other things. It also described the 6 hidden laws of the universe that underlie our entire world. But first of all, let's talk about the theory itself. Space vortex theory suggests that the universe is made up of vortices, or swirling patterns of energy. And according to SVT, these vortices are the fundamental building blocks of the universe. They're the driving force behind the laws of physics and the fundamental principles of our world. Basically, everything in the universe is connected and interconnected through these vortices. This theory isn't very based on any real observations, but rather on mathematical models and computational modeling. For example, some computational models showed how these vortices work in hydrodynamics and plasma physics. They showed that vortices in such systems can have a central point of attraction and can be interconnected. Other models were used to study how the energies inside the vortices move and how they can create different frequencies and vibrations. But some experts have criticized SVT for using only models and simulations. The biggest criticism is that this theory can't actually be tested. It relies on mathematics and not on some experimental data. That's why it's not accepted as a mainstream scientific theory. But it's still quite interesting and provides a unique perspective on the universe and our understanding of the laws of physics. For example, according to SVT, the universe has some underlying hidden rules that cause the creation of fundamental matter, their assembly, and movement. What are these laws and what do they say? Well, let's take a look at them. Law 1. The universe has only one primordial entity, space, i.e. absolute vacuum, that structures matter. This law states that space is the fundamental building block of the universe and that it's responsible for structuring matter. It suggests that space is the fundamental entity that creates and maintains the structure of matter, and that all matter in the universe is made up of the same fundamental particles, like electrons and positrons. Let's try to put it in simple words. Imagine that the universe is like a big Lego set. Just like how all the Lego bricks are made up of the same basic building blocks, the universe is made up of the same fundamental building blocks too. And these blocks are called electrons and positrons. But what holds these blocks together? Space, of course. Space gives it shape and structure, just like how the plastic container holds all the Lego bricks together in a set. So, the first law states that space is the fundamental building block that structures matter and holds everything together in the universe. Law 2. Matter is constituted with multiples of only one kind of fundamental particles, electrons and positrons. This law states that all matter in the universe is made up of the same fundamental particles, the electron and positron. These two are the Lego blocks we've talked about before. And, according to the second law, these tiny invisible particles make up everything, from a tiny atom to a giant galaxy. Just like no matter what the shape or size our Lego build is, it's still made up of the same building blocks. Law 3. The field distribution in space, as recognized by contemporary physics, linked with and emanating from matter, are effects arising from only one fundamental field in space. This law states that the fields recognized by contemporary physics, such as the electromagnetic and gravitational fields, are effects arising from a single fundamental field in space. It suggests that this fundamental field is responsible for creating everything that we observe in the universe. So let's try to put it simply. This time, imagine that the universe is like a big playground. All the different fields we observe, such as the gravitational and electromagnetic fields, are like different games we play in there. But no matter what we play, we're still in one fundamental space. This is the playground itself. It's the base that holds everything together. According to the third law, without the playground, we wouldn't be able to play any games. And without this fundamental field in space, we wouldn't be able to observe any fields in the universe. Law 4. There is no void in space anywhere in the whole universe except at the centers of the fundamental particles of matter, electrons and positrons. This law states that there's no truly empty space in the universe and that all space is filled with the fundamental field, the one we talked about before. It says that electrons and positrons can be found everywhere, and even the things we consider to be empty, like vacuum, are actually full of tiny particles. And according to this law, the only truly empty spaces we can find in the universe are at the centers of the fundamental particles, electrons and positrons. Law 5. From only one fundamental universal constant, all the constants considered universal in contemporary physics are derivable. This law states that all the constants considered universal in contemporary physics can be derived from a single fundamental universal constant. It suggests that all the constants in physics are interconnected and can be explained by a single fundamental principle. I know you've been doing a lot of imagining lately, but bear with me. This time, please imagine the universe as a big recipe. All the constants in physics, such as the speed of light, the gravitational constant, and the Planck constant, are like the ingredients. They're very different and there are tons of them. But just like how all the ingredients in a recipe are interconnected and come together to make one dish, all the constants in physics come together to make the universe. And just like how a recipe has a main ingredient that holds everything together, physics also has a single fundamental constant that holds everything together. Law 6. The spatial structure of submicrocosmic fundamental matter is repetitive uniformly in the spatial structures of macrocosmic bodies like planets, stars, and galaxies. This law states that the structure of the fundamental particles that make up matter is repetitive and uniform across all scales, from subatomic particles to macrocosmic bodies like planets, stars, and galaxies. It suggests that the same fundamental principles govern the structure of matter at all scales. Let's go back to the analogy with the recipes and cooking. Using different ingredients and combining them in different ways, the chef can create new dishes. These will all be different dishes and they can be very simple or very complex. But when creating them, the chef still applies the same basic rules and knowledge they have, right? And just like that, the universe also creates different structures, from atoms to planets, stars, and galaxies. But it still uses the same fundamental principles to create all these things. So, this law suggests that the structure of the fundamental particles that make up matter is repetitive and uniform across all scales. These are the 6 fundamental laws of the universe according to the SVT, and even though it's not accepted by mainstream science, it's still a pretty interesting concept.
You're traveling through deep space, circling stars and entire galaxies. Whoa, looks like this multicolored nebula will soon collapse under its own weight and explode like a supernova. Now let's carefully circle this black hole. Try not to get caught in its gravitational field, or it'll swallow you like a space monster. Wait, what's that strange structure right there? It's a glowing wall. And if you look closely, each glowing dot is an entire galaxy. That wall has about 100,000 of these galaxies. The Milky Way has 100 billion stars. So this wall holds a quadrillion, that's 10 followed by 15 zeros, of stars like our sun. This giant structure is called the South Pole Wall. It's located about 500 million light-years from Earth. By comparison, the closest star to our home is Proxima Centauri, and it's about 4.2 light-years away. Rockets can cover that distance in about 73,000 years. So the journey to the South Pole Wall may take longer than our solar system exists. And this wall is simply gigantic, even on a cosmic scale. It's about 1.37 billion light-years long. To give you an idea of how large that is, the Milky Way is only 100,000 light-years wide. But you can't see this wall even with the most powerful telescope. The problem is that the Milky Way itself obstructs your view. It's so bright that it's hiding this wall. It's like trying to look at the starry sky in a metropolis. The light pollution won't let you do that. Scientists have been able to detect this galactic wall by measuring redshift. We know that all objects in the universe are moving. They spread out from each other as a result of the Big Bang, which happened billions of years ago. And when galaxies move, their light waves change slightly. By measuring this change, we can understand what the object is and how it moves. And this wall isn't even the largest in our universe. This is the Hercules Corona Borealis Great Wall. It's a giant flat superstructure about 10 billion light-years wide. That's around 10% of the entire observable universe. And it's also a wall. That is, a cluster of galaxies. We were able to detect this giant structure by gamma-ray bursts. It's the brightest electromagnetic event in the universe. You could even see it in the far reaches of our universe. Such bursts are a very rare event. In the Milky Way, for example, it happens once every few million years. If we notice many such bursts in a short time from the same place, it means that there are many objects like the Milky Way in that place. So, there are a lot of galaxies out there. Another unusual giant structure in the universe is the huge, large quasar group. It's about 4 billion light-years across. So, it takes a photon of light almost as long as our planet has existed just to get from one side of the structure to the other. And if you put the huge, large quasar group on the scale, it would be 6.1 billion times heavier than our sun. Scientists have found that there are at least 73 quasars in that structure. These are some of the most unusual objects in the universe. They are the active cores of galaxies. At the center of a quasar is a supermassive black hole. This giant eats up the matter around it. A wild force of gravity twists the matter around the black hole, forming a disk. And this disk is the source of the strongest radiation out there. By comparison, the radiation from a single quasar is tens or hundreds of times stronger than that of all the stars in our galaxy put together. Because of such strong radiation, we can detect quasars, even at very long distances. That's why they're also called beacons of the universe. Scientists use quasars to study the universe and the movement within it. One of the most distant quasars from us is about 13.1 billion light-years away. This makes it one of the oldest objects in the universe. It appeared about 690 million years after the Big Bang, and it's almost 3 times older than our solar system. It's still glowing with extreme brightness, about 4 and 14 zeros times brighter than the sun. Scientists explain that at the center of the giant is a supermassive black hole, 800 million times heavier than the sun. All these giant structures are just building blocks of our universe. Look, this is our solar system. Now, zoom out a little, and this is where our home star is in the Milky Way galaxy. Zoom out again. Here's a local group of galaxies. All the bright spots here are galaxies. Here's Andromeda, and here's the Triangulum galaxy, plus a few dozen other slightly smaller galaxies. They're all gravitationally connected. The size of this structure is about 10 million light-years. That's 100 times the width of our galaxy. Zoom out, please. This one is the Virgo supercluster. It's 20 times larger than the local group. There are about 30,000 different galaxies, and the mass of the whole thing is about 1 in 15 zeros solar masses. Zoom out again. Laniakea. This structure is almost 3 times larger. It includes the Virgo supercluster and other smaller clusters. And there are about 100,000 galaxies here. It's not over yet. Zoom out one more time. Here's the Pisces-Cetus supercluster complex. This giant galactic structure contains about 60 clusters of galaxies. So there are more galaxies in it than grains of sand in the desert. You know what to do. Zoom out! Phew! This is the observable universe. There are over 500 billion galaxies. And the stars? Well, there are about 1 billion trillion stars. The observable universe has its own structure. Clusters of galaxies form chains and walls, as you've seen before. But these strands are separated by huge regions of absolute emptiness. These areas are called voids. In these places, there is no matter at all. There are fewer molecules in the voids than in an empty room. One of these voids has a very mystical reputation. It's the Eridanus supervoid, or the cold spot. It appeared here only 380,000 years after the Big Bang. It's almost 1 billion light-years wide and could hold hundreds or thousands of galaxies with trillions of stars. Some scientists believe that this cold spot may have been the result of the largest collision ever, a collision of universes. There's a theory that our universe is some kind of bubble, a huge sphere that contains all these walls and chains of galaxies. Now imagine that there's an infinite number of these bubbles. They could be parallel worlds or different universes. Many years ago, one bubble came close to the bubble of our universe. Their walls touched, and the two universes connected for a while. It's like 2 drops of water coming together. But that universe kept moving. The area where the bubbles joined became thinner and thinner until that connection broke, and the 2 bubbles detached from each other. At this point, the second universe ripped some of the material out of our bubble. All those galaxies that used to fill the Eridanus supervoid ended up in a parallel universe. Scientists supposed we might travel through other bubbles. Flying to the supposed wall of our universe would take forever, and then it would take even longer to fly through interuniversal space. So we have to use portals, or wormholes. Here's how it works. Imagine a piece of paper with point A on one side and point B on the other. Instead of moving all the way across the sheet of paper, we just fold the sheet so that point A is right above point B. All that's left to do is make a small hole, and the journey takes only moments. Some scientists believe that such shortcuts through universes lie inside black holes. But how do you survive falling into a black hole? You just have to pick one that's big enough. It's all about gravity. Imagine you're falling into a black hole right now. The closer you get to it, the stronger effect it has on you. It intensifies with every inch. At one point, the gravitational force that affects your head is much stronger than the one that affects your feet. Then you turn into spaghetti. Yum. But if you choose a supermassive black hole, like the ones at the centers of galaxies, the gravitational force in them increases gradually. They can be millions of times heavier than the sun and much bigger. But the gravitational force on your head and your feet will be almost equal, and you will still feel comfortable. Who knows? Maybe if you manage to survive a fall into such a massive black hole, you'd find yourself in a completely different universe where different laws of physics apply. But so far, this is just a theory. 13.8 billion years ago, a mysterious explosion happened in space. It was chaos, a time when the stars, planets, asteroids, the rest of the space bodies, and galaxies were born. It was the Big Bang, a theory we all know about. But no one knows for sure what happened, where the universe came from, and what was there before. Some even think the universe went through a cycle where it contracted and expanded several times. In 1991, a cosmologist from Stanford University named Andre Linde had submitted an article with the main idea that there was a possibility the universe had been created in a laboratory. His theory said there was a chance an advanced civilization somewhere out there had created our universe. This civilization has made an entirely new cosmos that later evolved its own planets, stars, and intelligent forms of life. 30 years later, many scientists take this theory pretty seriously. They even started talking about things that we, as a civilization, can do to get to such an advanced level. The theory says this advanced civilization decided to add technology that helped to create a new universe out of nothing. It happened through quantum tunneling. It's when an atom can appear on the opposite side of some barrier, even though it's supposed to be impossible, considering the laws of physics of our world. Like if you wanted to pass a tall wall, but you can't pass it with ladders or go around somewhere. Imagine you can just walk through it like a ghost. In our world, it's not possible, but a more advanced civilization perhaps can do it. Plus, they realized how they could create new universes. Right now, on the cosmic scale, we could be a Class C civilization. We don't know how to recreate some things. For example, conditions on the Earth for when our central star, the Sun, goes out. If we manage to become a Class B civilization, we'll learn to adjust conditions to be independent of the Sun. That means we might be able to learn how to live even without it. And if we level up and become Class A, we'll know how to recreate cosmic conditions and produce our own cosmos in our laboratories. We think of the world we live in through 3 dimensions of space: east-west, north-south, and up-down. There's also 1 dimension of time, which means we can distinguish past from future. A 5th dimension would represent 1 more extra dimension of space. The theory of its existence was first mentioned in the 1920s. It was inspired by the theory of gravity by Albert Einstein, who said space-time is warped by matter and energy. We can't perceive these 4 dimensions, but we see how an object moves and attribute it to gravity. And maybe there's some other force, like the electromagnetic force, that's more than 1,000 times stronger than gravity, that could explain things going on in that extra dimension of space. The 5th dimension is curved in a way we can't see it, but the idea about it was mentioned in a string theory. It considers the universe as really small strings of mass energy, not as particles. They vibrate in 10-dimensional space-time, considering 6 dimensions are rolled up way smaller than a single atom. That led to the picture of the universe as a 3D island that floats in 10-dimensional space-time. Also, the 5th dimension might be an excellent explanation to tell us more about dark matter. That's the invisible stuff with a mass, but we can't see it, nor can it interact with ordinary matter. And dark matter is 85% of all the matter in our universe. The universe can't be still. It's constantly in motion, either contracting or expanding. We used to think there were 100 billion galaxies, but it turns out there are more than 1 trillion. The galaxies are moving away from each other. This is what it means when scientists say the universe is expanding all the time. There are voids between galaxies that sometimes stretch millions and millions of light years across. They can seem empty, but they can also contain way more matter than we can find in galaxies. Still, stars usually can't be formed there because the matter between those areas has lower density. But there's still plenty of so-called intergalactic stars. A good example is the Virgo galaxy cluster, 10% of which are intergalactic stars. We don't know how exactly they got there, but there are two possible ways. 1. Stars can collide, merge, or pass close to another galaxy, which can kick it off from its parent galaxy. Option number 2. A supermassive black hole can accelerate a star to very high velocities if they have a close encounter, which can, again, make a star be expelled from its parent galaxy. If you could have a giant magnet, you could even pull something out from the vicinity of a black hole. That's possible if the magnetic field near a supermassive black hole is as strong as the black hole's gravitational field. But it doesn't work if we're talking about material that's already beyond the black hole's event horizon. That's a spot with a gravitational force so powerful, not even light can get away. You'd need to accelerate this material to the speed of light, at least, to get away. For that, you'd need an infinite amount of energy. But a magnet could help if something's heading toward the black hole but didn't get inside yet. When someone mentions a black hole, you might get a picture of some giant void in space. But the Milky Way is most likely full of thousands of smaller black holes that float around the galaxy. When a star comes to its end, it will destroy itself in a supernova explosion, which is a cataclysm of energy. In that explosion, the densities in the core will reach an intense enough state that nothing will be able to escape. At the same time, the major part of the star explodes outward, but a part of it collapses inward, creating a black hole. The bigger the star, the bigger the hole. The black hole then swallows everything that comes in its way, including other stars as well. When a star gets sucked up into the black hole, it's ripped apart because of the strong gravity inside the black hole. Some of its parts fall into the black hole, while others get ejected at incredibly high speeds. Some black holes might have been formed in a different way. The early stages of our universe were, to say the least, pretty chaotic. It had high temperatures and pressures, and was in a state that shaped the entire cosmos. Under the right conditions, any old gas patch may have shrunk itself to become a black hole. And they came in many different sizes, from something that weighs a couple of pounds to giant masses like thousands of suns, and those in between. They aren't really black. Black holes are areas with strong gravity, and no object can escape when it gets inside. They feed off electromagnetic radiation, such as light and space particles. Since they're consuming matter all the time, black holes give off a dark glow. The Earth is not that close to the inhospitable edge of the solar system. We're the 6th planet from it. Scientists made a pretty cool 3D map of our solar system where we can see what the edge looks like. It took them 13 years to design it. The boundary is called the outer heliosphere. It marks the area in space where the solar wind, which is the stream of charged particles our sun emits, gets deflected and draped back by the radiation coming from the empty region beyond our solar system. The inner layer of the heliosphere is where the sun and the planets have a rough shape of a sphere, while the outer layer is not that symmetrical. This asymmetry happens because our sun is moving through the galaxy and goes through friction with the radiation in front of it.
The Roswell incident is a collection of events and myths surrounding the crash of a mysterious object in 1947. Right after rubber and metallic debris was recovered by Roswell Army Airfield staff, the United States Army claimed that they had their hands on a flying disc. Just a day after this announcement was made and made international headlines, it was retracted, but the word was already out. To hide the true nature of the find, the Army stated it was a good old weather balloon. But later in 1978, a retired Air Force officer revealed that it was just a cover story. At the same time, he added that he was sure that the debris had an extraterrestrial origin. This speculation became popular thanks to the 1980 book, The Roswell Incident. It also turned into the basis for long-lasting and increasingly contradictory and complex UFO conspiracy theories. Over time, they expanded the incident to include authorities hiding the evidence of other space civilizations, multiple crashed flying saucers, alien bodies, and even reverse engineering of extraterrestrial technology. However, none of those theories were based on any real evidence. But despite the absence of proof, many supporters of the UFO theory claimed that the Roswell debris was from a crashed alien craft. They accused the authorities of creating cover-up stories. This conspiracy narrative became a trope in movies, science fiction literature, and TV shows. No wonder that the town of Roswell is still promoting itself as the best destination for UFO-associated tourism. But what happened in this area in reality? The government's claim that a weather balloon had crashed at Roswell was indeed a lie. In 1994, the Air Force admitted that the recovered debris had actually been from an American balloon used to watch other nations. It was part of Project Mogul, an attempt to monitor anticipated nuclear tests that could be conducted by other countries. In 1997, an Air Force report called the Roswell Report, Case Closed, suggested that all those stories about alien bodies could have come from civilian witnesses who had seen parachute crash test dummies. The report also suggested that the witnesses might have combined several different events in their memories: the Project Mogul materials, the crash of test dummies, and a few other accidents that had occurred in the area. For many supporters of the UFO theory, though, those explanations sounded like the authorities planned to cover up their interaction with extraterrestrial civilizations. After all, in 1947, the USA, as well as some other nations, was in the midst of the flying saucer craze. People reported seeing bizarre objects in the sky. They claimed those were spacecraft piloted by aliens. It was against such a hectic background that a rancher discovered some highly unusual debris near Roswell, New Mexico. The material included tinfoil, sticks, and rubber strips. The next month, he took his findings to the Roswell sheriff. The man contacted the Roswell Army Airfield. After getting the wreckage, they issued that very extraordinary press release claiming that a flying disc had been found at a local ranch. The reasons for such an outrageous statement were unclear. In any case, the Roswell Daily Record picked up this press release right away, printing the story on the 8th of July with the headline, "RAAF captures flying saucer on ranch in Roswell region." That's when the military backtracked, announcing that it had been just a weather balloon carrying a radar target. That's a device that looks like a box kite made of foiled paper fastened to a balsa wood frame. The Roswell Morning Dispatch paid attention to this new claim and released a new story called "Army Debunks Roswell Flying Disc as World Simmers with Excitement."
It was the year 1952 when America first caught the flying saucer fever. A rash of strange sightings was reported in the skies over Washington, D.C. Were those unexplained radar blips, unidentified aircraft, or something much more outlandish? The Washington, D.C. sightings of the summer 1952 are also known as the Big Flap. But it all started in 1947 when a search and rescue pilot reported 9 saucer-like things flying like geese in a diagonal chain-like line. Their speed reportedly exceeded 1,000 miles per hour. Within mere weeks, the sightings of flying saucers were reported in 40 other states. Later, the explanations were found. The sightings were either hoaxes or misidentifications of known aircraft and natural phenomena, but a few cases remained unexplained. By 1952, the UFO investigation unit called Project Blue Book had been founded. It was led by Captain Edward Rubbold. He and his team would have continued to investigate a few dozen sightings per month, but for the April 1952 issue of Life magazine with an eye-catching headline, "There is a case for interplanetary saucers." The article made quite a convincing case. It spoke about 10 unexplained UFO incidents, claiming that the flying objects were extraterrestrial in origin. According to the Washington Post, after the appearance of the article, the number of UFO sightings grew more than 6-fold, from 23 in March 1952 to 148 in June. By July, the UFO mania was in full swing. All that was missing was a spark. And it happened before midnight on Saturday, July 19th, 1952. An air traffic controller at Washington National Airport spotted 7 slow-moving objects on his radar screen. They were far from any civilian or military flight paths. He called his supervisor and joked about a fleet of flying saucers. Simultaneously, 2 other air traffic controllers at National spotted a bizarre bright light hovering in the distance. It suddenly dashed away at breakneck speed. At Andrews Air Force Base, located nearby, radar operators detected the same unidentified blips. Those were slow and clustered at first, but then they raced away at a speed higher than 7,000 miles per hour. One Andrews controller looked out of his tower window and spotted something he later described as an orange ball of fire with a tail. A commercial pilot flying over the Virginia and Washington, D.C. area saw 6 streaking bright lights resembling falling stars without tails. 2 jets were sent to search for the UFOs, but every time they got close to the locations shown on the radar screens, the weird blips would disappear. By dawn of July 20th, the objects were gone altogether. Ruppelt, the lead investigator of Project Blue Book, found out about the sightings just a few days later after flying to Washington, D.C. and reading news reports. He tried to get to National and Andrews to interview the radar operators and air traffic controllers, but wasn't allowed to take a government-issued car. He had to fly back to Ohio with nothing. In a few days, UFOs were back over the Capitol. The same radar blips appeared again. Radar operators were wondering whether those dozen or so objects could be caused by a temperature inversion. That's a common occurrence in DC's muggy, scorching summer months. It occurs when a layer of warm air forms in the low atmosphere. It traps cooler air beneath. In this case, radar signals can bounce off the layer at shallow angles and create an impression of near-ground objects in the sky. To be safe, 2 more aircraft were sent to chase down the unidentified targets. The jets raced to a location targeted by radar, only for the blips to disappear. Eventually, one of the plane pilots saw a bright light in the distance and gave chase. But even though he was flying at maximum speed, he didn't manage to overtake the lights. At a press conference, representatives of the Air Force offered the public some easy-to-swallow explanations, having opted for the temperature inversion theory. After that, UFO sightings dropped from 50 a day to 10.
If space were filled with air, the implications would reshape our understanding of the universe and the very nature of space travel, astronomy, and physics. Here are the potential consequences and considerations in such a scenario. Space travel. Complexity. Current spacecraft are designed for a vacuum, where they encounter minimal resistance. In a universe filled with air, space travel would resemble atmospheric flight, requiring spacecraft to be aerodynamic and robust enough to withstand air resistance and the heat generated from friction. Rockets would have wings. Rockets would need significantly more fuel to achieve the same speeds and distances, making space travel more complex and costly. Satellites would need constant propulsion to stay in orbit, as atmospheric drag would cause them to slow down and fall back to Earth. This would make maintaining satellite networks for communication and GPS far more complex and resource-intensive. Breathing in. Space. The presence of air might imply that astronauts could breathe in space, eliminating the need for spacesuits and life support systems. However, if the air's composition and pressure were not suitable for human survival, or if temperatures were extreme due to solar radiation heating the air, protective measures would still be necessary. Thermal dynamics. Space filled with air would have vastly different thermal dynamics. Heat from stars would warm the surrounding air, potentially leading to extreme temperatures across the universe. This could create a range of environments from scorchingly hot near stars to bitterly cold in areas far from stellar heat sources, affecting the habitability of planets and the feasibility of space exploration. Sound propagation. Unlike the current vacuum of space, air would allow sound to travel. This means that the noises of cosmic events such as supernovae or colliding asteroids could be audible. This would not only change the experience of space, but could also provide new data for astronomers to study celestial events. Astronauts on spacewalks might hear the hum of their spacecraft, the whirring of satellites, or even the sounds of solar storms and cosmic events, altered physics. The fundamental laws of motion and energy would behave differently in a universe filled with air. Spacecraft and objects would lose momentum due to air resistance, and the propagation of electromagnetic waves would be affected, potentially altering how we observe and measure cosmic phenomena. Astronomical observations. The clarity of observations made from within an air-filled space would decrease due to the scattering of light by air particles. This would complicate astronomical research and observation, making it harder to study distant stars, galaxies, and other celestial bodies without the clear view we currently have from Earth and space telescopes. Telescopes would struggle to get clear images due to the scattering of light by the air. Stars and galaxies would appear blurry, and many of the deep space discoveries we've made would be impossible with our current technology. Cosmic radiation shielding. While air could offer some protection against cosmic radiation compared to the vacuum of space, its effectiveness would depend on the air's density and composition. This might not suffice to protect humans and the electronic equipment from the high-energy particles prevalent in space. Orbital mechanics. The presence of air would also affect the orbit of celestial bodies. Planets, asteroids, and comets would experience drag as they moved through space, potentially leading to orbital decay and altering the dynamics of solar systems and galaxies. With air resistance slowing down space debris, Earth might experience more frequent but less intense meteor showers as objects in space burn up in the denser atmosphere at higher altitudes. Evolution of stars and galaxies. The life cycles of stars might be different in a universe filled with air. The processes of star formation, supernovae explosions, and black hole formation would be influenced by the interaction with the surrounding air, possibly leading to different types of astronomical structures and phenomena. Living and working in space would be different in such a universe. The experience of walking on a planet without a spacesuit and hearing the sounds of space would be profound. However, the challenges of dealing with the dynamic and potentially hostile environments created by air and space would necessitate new strategies and technologies for exploration and habitation. In conclusion, an air-filled universe would present a radically different reality from what we know today. The physics of movement, the nature of space exploration, the methods of astronomical observation, and even the sounds and sights of space would be transformed. The challenges would be immense, but the opportunities for discovery and understanding would be equally vast.
This is the James Webb Space Telescope, and this is how far we can see through its eyes. Impressive. But let's zoom further. Further! Further! The image is getting blurrier and blurrier. Wait! What is this shadow? It's a giant telescope capable of seeing those seemingly blurry images in perfect detail. NASA's Roman telescope is to be launched in 2027, and it might help us unravel the mysteries of the universe, including the essence of dark matter. No worries, James Webb will continue to show us the beauty of the cosmos and solve mysteries one by one. But astronomers have a new mission these days. They want to deploy the next, even bigger space telescope, and this mission is already well underway. The Nancy Grace Roman Space Telescope is likely to start a new age for astronomy. Scientists hope that the telescope will gather more data than any other NASA mission has ever done. Hubble and Webb are incredibly good at zooming in to get a clear, detailed view of small parts of the sky. Meanwhile, Roman is going to provide us with a much wider field of view. It will be capable of creating infrared images 200 times larger than Hubble. At the same time, it will have a similarly high level of detail. But even though the new telescope will be able to produce perfect images, it's going to be used mainly for surveys. Let's say we need to look for the star population in a nearby galaxy. But it's a too large field of view for Hubble. If we use it, we'll have to stitch lots of different shots and create mosaics out of them. But with Roman, a picture of the entire galaxy can be taken in one single shot. Look at this recent mosaic of our neighbor. the Andromeda Galaxy. This image was put together using 400 individual images taken by Hubble. And Roman will paint the same ultra-vast picture with the same level of detail with just 2 images. It not only sounds cool, it also means an unprecedented amount of data collected. Once we have such a panoramic view of the universe, NASA and other space agencies will probably be able to answer some of the greatest questions that have been intriguing humanity for ages. One of the main goals is to test the theory of relativity suggested by Albert Einstein. It's been well tested on the scale of our solar system, but not so much on larger cosmological scales. According to this theory, visible matter is supposed to slow down the expansion of the universe. But the universe is expanding non-stop, and doing it faster and faster. So, astronomers attribute this ever-growing expansion speed to a mysterious component, dark energy. They believe that it makes up around 68% of the universe. Hopefully, Roman will provide us with data that will help us accurately measure the position and distance between us and millions of galaxies. Eventually, it might let us figure out the expansion rate of the universe in different areas. In the end, the results might tell us whether Einstein's theory of gravity needs modification. One more of Roman's main goals is to detect hundreds and thousands of new exoplanets within our home Milky Way galaxy. The telescope will be able to do it using the technique known as gravitational microlensing. You see, when 2 stars align with each other, the one positioned in front distorts and magnifies the light of the other star located behind. And if the star in the foreground has a planet, we can see how this planet affects the light of the star behind it. Roman will hopefully count billions of stars, providing us with a very good census of how many of these stars have exoplanets. The cutting-edge telescope will not only spot new exoplanets, it will also carry another crucial instrument called a coronagraph. It can image exoplanets that are close to their parent star. This is actually an extremely tricky technique since the starlight has to be suppressed. After all, it's much brighter than the objects you want to study. By those objects, I mean nearby planets. The chronograph on the Roman telescope will try to capture large Jupiter-like planets directly by conducting live corrections to improve the quality of images. If it proves to work properly, the telescope will make a great demonstration instrument, forming the baseline for the technology that will be used on future space observatories. Such observatories will be capable of directly capturing Earth-like planets in the habitable zone of their parent stars. But the Roman Space Telescope isn't the only project that can change the way we explore space. There are other concepts, like Nautilus. It's an idea of a revolutionary space telescope based on a novel technology: special optical elements. Such elements can potentially allow us to overcome the main limitations of space telescopes: non-scalable primary mirrors. The Nautilus technology can provide large but ultra-light telescope apertures, enabling the launch of a massive fleet of identical telescopes. They will have an impressive light-collecting power, which will help Nautilus survey thousands of Earth-sized planets located in the habitable zone of their stars. As a result, we might find atmospheric signatures of life on those planets. Over the past 2 billion years, the atmosphere of our planet has changed dramatically. The abundance of free molecular oxygen and ozone, which are highly reactive gases, together with water vapor and methane, represent a unique atmospheric composition. The presence of these gases, biosignatures, in the atmosphere of our planet is a sign of life that can be detected from afar. We're speaking about galactic distances here. But to identify such fingerprints of atmospheric components in the light reflected by or transmitted through the atmospheres of Earth-like planets, we need very large telescopes. NASA's Kepler mission has discovered more than 4,000 planets. And still, no existing, or even planned, space telescope has a diameter that is large enough to search for life in exoplanets' atmospheres. Finding and interpreting observations of extraterrestrial life correctly is very difficult. But the Nautilus team hopes to build a telescope capable of studying thousands of Earth-like planets. Then, there's the European Space Agency's Euclid mission. It's designed to explore the composition and evolution of the dark universe. The mission was named after Greek mathematician Euclid, who lived in Alexandria around 300 years BCE. He founded the subject of geometry, and since the density of energy and matter is tightly linked to the geometry of the universe, the mission was named in his honor. This space telescope will create a great 3D map of the large-scale structure of the universe across space and time. It'll do it by observing billions of galaxies across more than a third of the sky. Euclid will try to figure out how the universe has expanded and how its structure is formed over the course of cosmic history. Hopefully, it will reveal more about the role of gravity and the very nature of dark matter and dark energy. As we already know, dark energy likely accelerates the expansion of the universe. As for dark matter, it controls the growth of cosmic structures. But experts remain unsure about what dark energy and dark matter are. By observing the evolution of the universe over the past 10 billion years, we might finally figure out how it has been expanding and changing. From this, astronomers might infer the properties of dark energy, dark matter, and gravity. It could help find out more about their precise nature. The Euclid spacecraft is around 15 feet tall and 12 feet wide. It consists of two main components, the payload module and the service module. The payload module includes a 4-foot diameter telescope and two scientific instruments, a visible wavelength camera and a near-infrared camera, or spectrometer. As for the service module, it contains satellite systems, such as electric power generation and distribution, data processing electronics, thermal control equipment, and so on. Recently, Voyager 1, a space probe designed to study the outer solar system and interstellar space, started sending truly bizarre messages to Earth. It was impossible to decipher them. Scientists were perplexed. Were extraterrestrial civilizations trying to tell us something? It turned out not to be the case. Apparently, the spaceship has encountered serious problems on its space voyage. Currently, NASA is trying to reach across 15 billion miles to rescue the probe. Unfortunately, spacecraft can't live forever. Last year, Voyager 1 started beaming home total nonsense. And if before it was a string of binary code consisting of ones and zeros, now it's something unintelligible. It means that billions of miles away from home, beyond the protective bubble surrounding the solar system, Voyager 1 is in big trouble. The Voyager 1 team on Earth traced the problem to the probe's flight data system. It's an onboard computer parsing and parceling all kinds of science measurements for further radio transmittal to Earth. One theory claims that it could have been struck by a high-energy cosmic particle, which caused problems with the system's memory, like a bit flip. Bit flips occur when you're copying data, and one of the bits changes, making everything incorrect. A value of 1 becomes a 0, or vice versa. Usually the team simply asked the spacecraft for a memory readout. It allowed them to find and reset the errant bit. But this time, they don't know where the bit flip is because they can't see what the probe's memory is. And it's the most serious issue they've had in a long time. It's very worrying because they've lost communication with the spacecraft. But recently, the team has managed to break through to Voyager 1. After months of stress and failed attempts, they finally managed to decode a portion of the spacecraft's gibberish. This might allow them to find a way to decipher whatever it's trying to say. While you're watching this video, Voyager 1 has already traveled around 10,000 miles of almost empty space. Voyager 1 and its sibling, Voyager 2, are slipping away from us at incredible speeds. Sooner or later, they're bound to fall silent. The Voyagers are very important to humanity, as much as they're beloved. The Voyager missions were supposed to exploit a once-in-175-year alignment of Jupiter, Saturn, Uranus, and Neptune to slingshot through our solar system, exploring its most distant regions. Outfitted with nuclear power sources, these space probes were built to last. Nearly half a century later, the probes are still the farthest flung and longest-lived missions ever sent into the cosmos by people. Voyager 1 is the front-runner, and its sibling is trailing close behind. In the years 1979 to 1981, the Voyagers zipped by the gas giants of our solar system, sending stunning images of Jupiter and Saturn, as well as their collection of moons, to Earth. Voyager 2 then went on to explore the ice giants, Uranus and Neptune. Those were actually the first and so far only times people had seen those bluish worlds up close. After that, the Voyagers left the realm of the known planets. Each of them followed its own path into darkness. Voyager 1 moved up and out of the plane of the solar system, while Voyager 2 looped downward. As the Voyagers traveled farther from Earth, the team switched off many onboard instruments, including the cameras. But the spacecraft kept studying the space they were flying through. Their main task was to examine the heliosphere, that protective bubble around our solar system formed by the sun's wind and magnetic field. It blocks cosmic rays, protecting us from space radiation. The Voyagers were supposed to document the unfamiliar mix of particles and fields, escape the solar system, and turn into real interstellar wanderers. It happened in 2012. Voyager 1 crossed the boundary where the sun's influence waned, and if before we could only make guesses about what was beyond that barrier and how it shielded Earth from the harshness of the cosmos, now Voyager 1 could tell us directly about the stuff filling space between stars. Voyager 2 followed its sibling in 2018.
Asteroid strikes, gamma-ray bursts, supernovae blasts, and other terrifying threats could potentially take out humanity. But one of them is inescapable, a cataclysmic event that will happen around 1 billion years from now and most likely rob our planet of its oxygen, effectively wiping out all life forms. Nearly 2.5 billion years ago, there was a period called the Great Oxidation Event. It gave us a breathable atmosphere, thanks to which we're all alive today. Cyanobacteria, also known as blue-green algae, appeared on Earth, filling the atmosphere with oxygen. It eventually led to the appearance of a world filled with multicellular life forms. But then, one of Earth's greatest die-offs occurred. It happened 450 million years ago. This event is known as the Late Ordovician Mass Extinction. Scientists think it might have happened because the inverse process took place. The level of oxygen on the planet dropped dramatically, and it lasted for several millions of years. It's unclear what could have caused such an extreme event. During this period, the continents formed one jumbled mass called Gondwana. Most life on Earth lived in the oceans, but plants were starting to colonize land. Near the end of the Ordovician period, a climate shift covered the supercontinent with glaciers. This dramatic cooling alone was enough to lead a lot of species to the brink of extinction. And then, oxygen levels plummeted, which caused the second wave of extinction. Scientists have found evidence of this event in seafloor samples gathered from all over the world. Some are sure that glaciers were responsible for changing the layers of the oceans, which had previously had unique temperatures and specific concentrations of elements like oxygen. However, the exact cause of the oxygen drop is still unclear. Whatever the cause, more than 80% of life on Earth disappeared during the Late Ordovician mass extinction. Could a deoxygenation event happen again? Some researchers draw an eerie comparison to today's situation. They say that climate change is already reducing oxygen levels in our oceans. It's likely to make loads of species go extinct and the world to change beyond recognition. Now, even if global cooling triggered the Late Ordovician mass extinction, what sparked this process in the first place? There's a theory claiming it could have been a gamma-ray burst. These bursts seem to be the most violent and energetic explosions in space, and they might be related to supernovae. Thankfully, we haven't seen such a burst close enough to fully figure out what it is. So far, they have only been spotted in other galaxies. If a gamma-ray burst occurred in our home Milky Way galaxy, it could also lead to a mass extinction on Earth. A burst pointed in our direction might only last 10 seconds or so, and still, it would destroy at least 50% of Earth's ozone layer. Yes, in such a short period of time. Even a relatively small amount of ozone depletion is enough to cause serious harm to our planet's natural sunscreen. And wiping out ozone on a large scale can wreak havoc, finishing huge numbers of species, starting with the ones living in the upper levels of the ocean. Gamma rays also break apart atmospheric oxygen and nitrogen. These gases turn into nitrogen dioxide, commonly known as smog. If this smog blanketed Earth, it would block out sunshine and trigger a global ice age. But our ultimate fate is much more dramatic than any of these scenarios. Most life on Earth will eventually disappear due to lack of oxygen after solar activity causes atmospheric oxygen to drop back down to the level it had been before the Great Oxygation event occurred. The sun ages and puts out more and more energy. At one point, around 1 billion years from now, Earth will reach the point where atmospheric carbon dioxide will begin to break down. That's when oxygen-producing plants and organisms will disappear. Earth won't have enough life forms to sustain the oxygen-rich atmosphere all living beings on our planet need. This process may take as few as 10,000 years, and it seems to be unavoidable. Luckily, we still have around 1 billion years to figure out how to save ourselves.
According to the theory of panspermia, life could have been brought to Earth by a meteorite, comet, or asteroid from a different region of space. At the moment, this idea remains purely theoretical. But let's figure out if it could actually turn out to be true. Traditionally, exobiologists, those who are focused on searching for life outside Earth, have been trying to explore the possibility of life on Mars or in the subsurface oceans of Saturn's and Jupiter's icy moons. But simple life could be much more widespread. It could be drifting through interplanetary space right now, in the form of dormant bacteria and spores. Several scientists have noted that the ultra-harsh environment of space is likely to severely damage the DNA and RNA of such spores and microorganisms. Others believe that since enough microbes could be traveling in a dust cloud, some of them could survive in their original form. There are several types of panspermia. For example, lithopanspermia proposes that some kind of microbic life could exist in debris blasted into the cosmos after planetary collisions with comets and asteroids. Radiopanspermia claims that organisms might be able to travel through space with the help of radiation coming from stars. But in this case, it's unclear how the effect of dangerous ultraviolet and X-ray radiation, combined with the vacuum of space, doesn't totally destroy microorganisms. There's also pseudopanspermia. According to it, organic building blocks of life appear in interstellar clouds of dust. They get transported to the surfaces of planets, and life starts developing there. It sounds really fascinating, but is there any evidence for the panspermia theory? Well, there have been a few orbital experiments. For example, from 2008 to 2016, the samples gathered by EXPOSE, special equipment mounted outside the International Space Station and dedicated to astrobiology, were exposed to the conditions of space. After that, they were returned to Earth from the ISS. It turned out that some of them had survived those severe conditions. There was even a case when 100% of bacterial spores placed in Mars-like conditions were still capable of life. Also, some seeds survived and were later grown as plants on Earth. There have also been exostack experiments on the U.S. Long-Duration Exposure Facility satellite and biopan experiments on Russian photon capsules. They have shown that with minimal protection, spores, lichens, and even minuscule animals, such as tardigrades, might be able to survive in space for as long as several years. A piece of Surveyor 3 lunar lander was brought back to Earth in 1969 by the Apollo 12 mission. Shockingly, it contained an Earth bacterium that had survived unprotected for more than 2 years on the airless surface. At the same time, this bacterium could have come from laboratory contamination on arrival back on Earth. The Indian Space Research Organization carried out a search for space microorganisms too. It was done at stratospheric altitudes via balloon flights. The results showed that living interplanetary cells existed in air samples taken from heights of above 25 miles. Normally, air from lower levels of the atmosphere can't be transported there, so this discovery seemed to prove the theory of panspermia. But in 2010, NASA atmospheric sampling before and after hurricanes proved that under certain circumstances, Earth bacteria could actually be transported very high into the upper levels of the atmosphere. One of the main arguments against panspermia is that if this theory was correct, all life found throughout the solar system would have a common origin and share main biochemical characteristics like genetic code. It doesn't sound plausible. Many specialists believe that only the presence of astronaut explorers on the surfaces of, let's say, Mars, Europa, or Enceladus can properly solve the question of life in the solar system. They can compare any life forms found with Earth-type life, which can turn out to be a real test of panspermia. In any case, until probes finally find direct proof of spaceborne life, the panspermia theory will remain unproven. The Hubble and James Webb Space Telescopes cooperate to explore space. Their observations complement each other and provide us with a broader view of the universe. But there are some significant differences between these two space explorers. Let's compare them. Currently, James Webb is the largest and most technically advanced telescope we've ever built. It can peer back over 13.5 billion years, observing the first stars and galaxies forming in the darkness of the early universe. The telescope's infrared vision cuts through massive clouds of gas and dust where planetary systems and stars form. This ability goes way beyond Hubble's infrared view, used for studying distant exoplanets. Hubble can actually observe space in near-infrared light, but it was optimized for shorter ultraviolet and visible wavelengths of light. This difference is what makes Webb and Hubble an awesome pair of observatories covering a broad wavelength range. Both Hubble and Webb are reflecting telescopes, which means that they use curved mirrors instead of lenses to gather and bend light to their numerous instruments. And still, these two have some obvious differences. Hubble observes the universe from an orbit just above Earth's atmosphere. That's why it needs to block stray light coming from the sun, as well as sunlight reflected by Earth and the Moon from entering the telescope. To accomplish it, the forward assembly of the observatory is wrapped in an insulated, aluminized Teflon light shield. This gives the telescope its tube shape. As for James Webb, it has a large, multi-layered sunshield that looks nothing like Hubble's light shield. And still, it serves the same purpose. Webb's primary mirror, which is more than 21 feet across, is way larger than Hubble's 7.9-foot one. No wonder Webb has more than 6 times the light collecting area that Hubble has. It's very important at the longer and dimmer wavelengths of light James Webb sees. You see, the universe is constantly expanding, and light from distant objects gets stretched when it travels to Earth. Shorter, bluer wavelengths of light stretch toward longer, redder wavelengths. That's why distant objects that look bright in blue or ultraviolet light turn red or redshifted once their light reaches Earth. They also get way dimmer. Webb's primary mirror gathers more of this dim, redshifted light, giving us clear views of objects 100 times fainter than what Hubble can see. Hubble is optimized to see ultraviolet and visible light. That's why its primary mirror doesn't need to be as cold as Webb's. More than 200 thermal sensors keep Hubble's instruments at optimal temperatures. An array of heaters warms the back of Hubble's primary mirror. That's where the observatory's science equipment is located. This part needs to be stiff and thermally stable. So Hubble's heaters maintain a temperature of 70 degrees F. As for Webb, it needs to be much colder than Hubble to capture those faint infrared wavelengths of light. The problem is, unlike visible light, we can't see infrared light with our eyes. But we can feel it because it's heat, or thermal radiation. When you turn your face toward the sun, you feel warmth. That's what thermal radiation is. To be able to capture the remains of the heat from objects so insanely far away, Webb needs to be extremely cold, minus 364 degrees F. To maintain this temperature, the telescope needs to shield itself from the infrared radiation coming from the Sun, Earth, and the Moon. That's why it has to be way farther from our planet than Hubble. Hubble orbits Earth 326 miles above the surface of the planet, but Webb orbits the Sun with Earth around 1 million miles away from home. From its perspective, the Sun, Earth, and the Moon are always in the same part of the sky. It allows the observatory's enormous sun shield to block the light coming from these space objects and keep the telescope cool. The gravitational forces of Earth and the Sun also make it convenient and easy for the telescope to hold its orbit. Webb only needs an occasional modest rocket thrust to keep its steady orbit. As for Hubble, due to its close proximity to Earth, it needs to deal with a dent in our planet's magnetic field. This dent is called the South Atlantic Anomaly, and it collects charged particles from the Sun. It tends to cause communication disruptions and problems with electrical systems. Hubble has to pass through this region 10 times every day, staying there for nearly 15% of its time. One pretty bizarre theory claims that space is water, and we're here to figure out whether it's a legit scientific idea or a fallacy resulting from myths and legends. Spoiler alert, you might be in for a surprise. Space is an almost perfect vacuum that has an extremely low density of hydrogen molecules, helium, dust particles, and plasma. As for water, it consists of hydrogen and oxygen. While hydrogen is the most abundant element in the universe, as well as the main material for the formation of stars, oxygen in space is mainly formed by the fusion of helium and carbon nuclei. It happens during the nuclear fusion process of stars that can be at different stages of their evolution. No wonder that there's much less oxygen than hydrogen in the universe, but it's still enough to form water in different states. For example, water molecules can be found on dust particles in molecular clouds, cold and dense regions of outer space. They are also present in interstellar space. There, they take the form of gas or ice on the surface of comets, asteroids, planets, and moons. The surface of some satellites of Saturn and Jupiter are covered with ice crust under which there's probably liquid water. Venus and Mars have gaseous and liquid water in their atmospheres. On our home planet, water covers more than 70% of its surface. In other words, space is filled with water, but it's distributed extremely unevenly. Interestingly, people started to compare space to water long before they found out what the cosmos was actually made of. The very theory that space is water dates back to the times before the current era. For example, some ancient civilizations believed that the ocean was a portal to space. Of course, in the physical sense, there's no direct connection between these two. But both represent a huge space with different mysterious inhabitants which people have been trying to study for a long, long time. People in the past believed that the ocean and stars were linked. Thousands of years have passed. People have mastered sea navigation, but we still haven't solved all the mysteries of the deep sea. Just like we don't know all that much about space. What giant monsters can be hiding in its depths? Only 2 to 5% of the world ocean has been explored, and space has been explored by the same percentage. For example, dark matter, making up most of the universe, is still a mystery to us. Of course, in a physical sense, space doesn't behave like water. But both water and space are fatal. Without a special suit and equipment, you won't be able to breathe, and there's also decompression sickness threatening your life. Only in space, it's a lack of pressure, while in the depths of the ocean, it's either too much pressure or a dramatic pressure drop due to the fast rise from the depth to the surface. Even if outer space is not water, could it be liquid? One study suggested that the vacuum of outer space could be a dilatant fluid, also called shear thickening fluid. This theory is based on the so-called Pioneer anomaly, a decades-old astrophysical mystery involving 2 NASA space probes. In the 1970s, 2 NASA spacecraft, Pioneer 10 and Pioneer 11, started their journey toward Jupiter and Saturn. Observing their trajectory, scientists from NASA noticed that the probes started to slow down. Of course, the scientific community began to offer different hypotheses. One of them suggested that thermal radiation emitted by the probes in space could have created some pressure on their surface. It could be slowing down their movement. Eventually, after additional research, it was concluded that the physical vacuum most likely behaved like a dilatant fluid when the shear stress increased. Later, another scientist managed to find some proof that space-time can behave like a fluid. You see, according to Einstein's theory of relativity, space-time curves around mass and energy. That's what leads to an effect we know as gravity. But apparently, if you write down the equations of sound waves moving in liquid, they will look the same as the equations of waves traveling in a gravitational field. Such a mathematical relationship between fluids and gravity is called analog gravity. The researcher also managed to recreate these gravitational analogies in a lab. At the moment, the results of these experiments are still controversial, and many scientists don't support this theory. Even so, maybe the idea that outer space is liquid isn't so unfounded?
If you want to cook pasta, take a large star that is about to go out and boil it until it goes supernova and explodes. You might need to wait for 1 billion years till it happens, so you'll need all the patience you've got. After the explosion, gather all leftover protons and electrons and vigorously stir them inside the star's shriveled core. Have they merged into a soup of immensely dense neutrons? Time to apply as much gravity as possible. Now, squash the stew into an airtight sphere the size of Chicago and cover the dish with a crystalline crust. Finally, heat it up to 1.08 million degrees Fahrenheit. What are you saying? It doesn't sound like a pasta recipe? That's because you've just made one of the strangest and strongest concoctions in the universe: nuclear pasta. For a few years, astrophysicists have been contemplating the idea of the existence of nuclear pasta. Such tangles of matter might be moving around inside neutron stars. Once a star becomes too old and massive, about 4 to 8 times as big as our sun, it doesn't have any fuel left. The reactions in its core slow down and then stop completely. The star's outer layers try to collapse inward, but they bounce off the core, which remains incredibly dense. That's when everything but the star's core blasts out all over the universe in a bright supernova explosion. But that's not the end of the star. Even without the outer layers, its core keeps collapsing. At one point, the pressure inside becomes so great that electrons and protons melt into each other and form neutrons. The result of this crazy fusion is a neutron star, whose mass consists of 90% of neutrons. It means that the resulting space object just can't be squashed any tighter. Then, energy starts to leave the fading star, transforming it into a neutron star. And the amount of this energy is so great that it can be compared with the combined light emitted by all the stars in the observable universe. Interestingly, neutron stars are relatively small. Even though scientists don't know for sure how big neutron stars can be, they suppose that these space bodies shouldn't be larger than 12 miles across. Nuclear pasta might be the only matter that can survive in a star after a supernova, and it may also be the strongest substance in the universe. In a new study, a team of scientists from the United States and Canada made several computer simulations, testing the potential strength of nuclear pasta based on everything we know about neutron stars and the conditions under which nuclear pasta is likely to form. The researchers determined that to shatter nuclear pasta, we'd need about 10 billion times the force needed to shatter steel. The incredible strength of nuclear pasta probably comes from its immense density. Nuclear pasta is believed to only exist inside neutron stars, and we've already spoken about how dense these celestial objects are. To exist in such extreme conditions, everything inside a neutron star has to become way heavier than it would be anywhere else in the universe. In 2007, a NASA blog post even claimed that a sugar cube's worth of matter would weigh more than 1 billion tons inside a neutron star. That's roughly equal to the weight of Mount Everest. According to a new study, nuclear pasta might be so strong and densely packed that it could layer up and form small mountains, capable of lifting the crust of some neutron stars. As neutron stars rotate, and they can do it unbelievably quickly, these lumps on the surface of stars might theoretically produce ripples in the surrounding spacetime. Such ripples are also known as gravitational waves. This phenomenon was detected when 2 neutron stars collided, but it's still unknown whether nuclear pasta had anything to do with this unique gravitational outcome. Further research is definitely needed. Popular images show Neptune as a beautiful deep blue planet, but it turns out that Neptune's real color is way paler. An analysis of photos taken by Voyager 2 has shown that Uranus and Neptune have a similar pale greenish-blue hue. NASA's Voyager 2 space probe flew past the outer planets of our solar system: Jupiter, Saturn, Uranus, and Neptune in the 1980s and sent back some images that clearly showed that Uranus and Neptune were colored differently. It confused scientists. After all, these planets have similar size, mass, and chemical makeup. Models of the atmospheres of these planets could probably explain some of the variations. For example, a haze layer is thicker on Uranus and reflects more white light. It makes the planet appear lighter. And still, it didn't fully explain why the planets had such dramatically different hues. But recently, Patrick Irwin from the University of Oxford, together with his colleagues, processed the images received from the Voyager 2 spacecraft to demonstrate how the human eye could see the planets. And it turned out that the original photos taken by Voyager 2 had an enhanced contrast ratio to highlight some atmospheric features that would otherwise be difficult to spot. Then, the colors were balanced to make a final composite image, and this made Neptune appear much bluer than it actually was. But the most interesting thing is that scientists knew about this at the time, and they did include these changes in picture captions. But over time, the captions were separated from the images, and Neptune's dark blue hue started to be perceived as fact. Irwin and his team created a model to convert the raw image data to a true color image. They used the shots taken by the Hubble Space Telescope. Those contain more complete data about the light. As a result, they received a shade that was very similar to that of Uranus. Unfortunately, the correctly colored image seems to be much more boring and bland, but that's just how our eyes work and how we perceive reality. The scientists also used the Hubble telescope images, as well as the images received with the help of Lowell Observatory in Arizona, to make a model that could predict how Uranus's color changes during its long orbit around the Sun. It takes the planet 84 Earth years to complete one revolution. Because of the spin of the planet, we tend to see more of the equator during the equinoxes and more of the poles during the solstices. But at the equator, there is a lot of methane. This gas tends to absorb red light. Plus, Uranus also has a shield made up of reflective, brightening ice particles. It forms at the sun-facing pole during the equinoxes. This increases the reflectivity of green and red wavelengths. It helps to explain the mystery of why Uranus seems to be a bit greener during its solstices. Interestingly, astronomers knew there was a hood surrounding the planet, and they knew that there was less methane at the poles. But until recently, no one has put it all together to explain what happens on the planet seasonally. But let's get back to Neptune for a while. There's a strange dark spot on this planet that has been recently observed from Earth for the first time. Astronomers managed to do it with the help of the Very Large Telescope in Chile. And now, after analyzing this blemish, researchers are almost sure that it's caused by dark particles deep within Neptune's atmosphere. Voyager 2 was the first to detect a shadowy region on the ice giant, which was later called the Great Dark Spot. Since then, the spot has been monitored with the help of the Hubble Space Telescope, which has revealed that such marks are nothing out of the ordinary for Neptune and disappear after a few years. And still, their nature remained elusive. But recently, Patrick Irwin and his team have started to use a ground-based telescope with a much wider spectrum of light. It split the light from the planet into different wavelengths, including the longer, redder part of the spectrum. It allowed the team to see the spot from Earth and analyze it better. That's how they found out about those dark particles creating bizarre dark spots.